Yeah. And also business-wise, we cannot do business. No one is taking decision.
And the problem is that it is very difficult for the sale activity, because without moving, and it is quite difficult to sell. We are not Amazon. We cannot sell by remote. It is very difficult. No?
You're right. You're right.
Yeah.
You're right. Because in the kind of business that Danelli is, or SMSs or Primetal is, it is very difficult to convince a customer from remotely, because
yeah. The contact with the customer, the fact to talk about the technical solution, what are the advantages, and to explain all the details at the moment cannot be made in an effective way by remote.
exactly.
If we have already a negotiation that is already started in the past, we succeed in finalize it in this month, also by remote. But if you have to start from the scratch, it is very difficult.
Very difficult. Danelli India just signed a contract with
Bashundra.
Yeah. That was done remotely. I mean, Danelli India sent the contract to them. They signed it in London, but in London, no one from Danelli was there to sign the contract.
Yeah. But that was a good let's say pilot to try for
the next day.
To work from remote on the sales part. That is a good project. It is a
very good project. That is by far the largest MEDA contract. And Bangladesh is a country which is investing a lot right now.
Yeah. It is a good opportunity for Danelli India, because of the internal market in India seems to be not so good. So if Bangladesh, if we can get the opportunities from Bangladesh, it is a good thing.
Yeah, and Mr. Menochi is also directly involved in the day-to-day projects in Bangladesh and this region, also in Myanmar.
Yeah.
Good afternoon, Mr. Gupta. Can you hear me?
Hi, Nemla. Good afternoon.
Good afternoon, Rohit. Good afternoon. Let me introduce you to Mr. Ardesi. He is the CEO of Danelli Digital Automation and looks after the Danelli Automation.
Good afternoon, Ardesi.
Good afternoon. Pleased to meet you.
Yeah. So we have another 15-20 minutes to go. Let me introduce Mr. Ardesi to my son Ankit. My son is doing his master's in data engineering, data science and knowledge engineering from University of Magdeburg, and he is right now in the city of Magdeburg, which is very close to Berlin.
Good afternoon, Mr. Ardesi. Nice to meet you.
Good afternoon. Nice to meet you.
He has a very good friend in Butrio. His name is Paolo Messina. I don't know if you know him.
Yes, I know him. It is in charge for all the marketing activities for the Danelli Group. Paolo. Yeah.
So Paolo is a very good friend of my son. So he calls him Junior. Yeah.
Good to know it. How is it going in Germany? How is the situation in Germany?
It's good now. Things are recovering. Things are under control. There is a third wave coming, they're saying, in south of Germany near Bavaria. But in the northern part, in the western part, most of the places are under control.
Okay.
How is the situation in Italy now?
In Italy, you mean?
Yeah.
In Italy, it is quite under control. We have some increasing in the last 2-3 weeks, but it is well below the situation that there is in other countries in Europe, like France or Spain, in which there is a big increase after the lockdown.
Yeah.
At the moment, we are under control. Let's hope that we'll go ahead in this situation. We should reopen also the schools in the middle of September. So now at the moment there is some concern about that, because they are planning the best way also for the transportation. That is the most critical thing for all the students. But okay, we will see in the next 2 or 3 weeks how the things will go. Really, for the moment we are in a good situation. We have a bad experience in February, March, and April, because okay, at that time we were in a very big difficulty. But at the end, we are recovering quite good.
At that time, I think it came as a surprise, and now people are more prepared for it.
Yeah,
so,
absolutely, absolutely. Anyway, it is on the end of the people at the end, because it is all a matter of behavior, and to stay very, very focused on the things that can be done and that cannot be done until some
vaccine comes along.
Vaccine have been found. We have to
Good afternoon,
cope
Mr.
with
Mohile.
this situation.
Hi, good afternoon.
Good afternoon.
Good afternoon, Mr. Mohile. May I ask you, Ardesi, did you receive the program? Do you have the program with you?
Yeah, I have it.
Yep.
Thanks.
Okay. So Mr. Mohile, Mr. Minesh Mohile is Associate Vice President, IT, Information Technology in JSW Steel. Minesh, you are in Bellary or you sit in Mumbai?
I sit in Mumbai. I was in Bellary for 4 years. Recently got shifted to Mumbai.
Okay.
Nice to meet you.
You are in BKC or you are in BKC?
I'm in BKC. Yeah.
Great. Pleasure. And let me introduce Mr. Rohit Gupta from L&T. He's
Good afternoon.
good afternoon to you. Mr. Praveen, can you hear me? Mr. Praveen, can you hear me?
I can hear you. I'm just trying to set up the virtual background. Hi. Good morning.
Yeah. Ankit, can you help Mr. Praveen to put up the virtual background? Just direct him where he should go.
No, I have done that. I have 1 minute. I'll start my video. Right.
Yeah, there you are. Good afternoon to you. Mr. Praveen is Digital Solutions Architect in ABB. I think, Mr. Ardesi, you know ABB. I don't have to introduce you to ABB.
Absolutely yes. They are our partner for many projects. So
I'm digital architect for metals globally.
okay. Nice to meet you.
Yeah. We have another 15 minutes. So I'm just taking, Ankit, you can take over. I'll just take a break for 10 minutes and be back.
Right.
Okay.
I think we should just wait for the rest of the panelists to join.
You can greet the panelists. I'll be joining you in 10 minutes.
Absolutely.
Just in 10 minutes.
Perfect.
So Ankit, do we share our slides or we just speak? What do you think is the right way to do it?
So if you have made a presentation, then you can share your screen and you can present.
Okay.
Yeah. So the share screen option is enabled for all the panelists.
In any case, we have about 10 minutes or so.
Yeah, about 8 to 10.
So not too much time for a big presentation. I think a couple of slides
Right, yeah.
is what we can project.
Good afternoon, Mr. Bhatt. You have to unmute your microphone.
Yeah, good afternoon. Now I think you can hear me.
Yes, we can hear you. So Mr. Manish Bhatt is the digital sales and marketing from SMS India Private Limited.
Hello.
Hi, Manish. Good afternoon.
Manish, good
Good
afternoon.
afternoon, sir. Good afternoon.
Good afternoon, Manish ji. Good afternoon, Ramda.
Good afternoon.
Manish ji, can you hear me? Ramda, can you hear me? Clearly?
Yes, I can hear you.
Manish, Manish just texted me. He will be back in about 5 minutes.
Okay. রামদা আমার ছেলের সাথে আমার পরিচয় হয়েছিল তো দেখা হয়েছিল
হ্যাঁ হ্যাঁ পরিচয় আছে আমার ছেলেকে খুব ভালো চিনি আমি অনেক কম বয়স থেকে চিনি
হ্যাঁ ও এখন মাস্টার্স করছে জার্মানিতে ম্যাকডিবার্গে ওভিজিইউ ইউনিভার্সিটিতে ডেটা সায়েন্স নিয়ে
এক্সেলেন্ট খুব ভালো the cutting edge technology
yeah so he is learning AI machine learning IoT all these are his subjects.
Very good, excellent. And Germany is the right place to learn all this.
Exactly.
Yeah.
Okay, Ravi has joined. Ravi, very good afternoon to you.
Good afternoon to you, Nirmala. How are you?
All well, Dada. And thanks to your daughter, we have Praveen. I'm sorry, we have Mr. Rohit Gupta from L&T also here.
Good.
Good afternoon.
Praveen ji, are you there?
I can see Minesh also.
Minesh is also yeah.
Hello, boss. How are you?
Good, Minesh.
Very good. Very nice to see you after a long time.
That you are now with JSW after seeing.
Yes.
So Minesh was with you in Tata Steel, or I mean, or
We were together in SRT.
In SR, okay. Great. So this is a platform I have created to meet old friends. Ramda is again a very old friend, and we know each other for quite some years now. The same goes with Ravi, whom I know for almost 20 years now.
Yeah.
So it's been a long relationship. Manish has not joined. Ankit, has Manish joined?
Yeah, he will be coming back in 5 minutes. He will be joining back. He just went for.
Okay. So we'll get started in another 10 minutes exactly. So till then, we'll wait for others to join. So I think Sabyasachi Da has not joined so far, right, Ankit?
Yeah, he has not joined yet.
It's very early for him. Must be around what, 6 o'clock or so. 5:40. Mr. Biswal, can you hear me? Mr. Biswal?
Yeah, I am able to hear you, sir. I am already in the meeting.
Yeah. Thank you, Mr. Biswal, for accepting a last-minute request because you know.
It's my pleasure and my first meeting webinar in life.
Yeah, actually, RINL has done a great job. That is why I wanted to ensure that RINL joins this.
We in a small way we are starting, sir, Industry 4.0. So in the last we had some meeting for the CSI. We had introduced this subject. Now we want to have it something concrete in the steel plant area.
Exactly. You
Okay,
can just in a few words you can explain what this rupees 30,000 crore allocation is for and how you are moving. You can just.
It's not like that. I'll tell you a bit of it. What happened sometime back in February this year? Okay, we had one. Start my video. We had one meeting from the Computer Society of India, where the topic was on Industry 4.0. So what happened? That meeting made the foundation for meeting all big people like our Dubey Saab and our chairman and other industry leaders. And we thought, okay, why not we do something for the startup ecosystem, for the startup people and this Atmanirbhar Bharat dream of government of India. So that is how, in a small scale, Dubey Saab came forward. He discussed with our chairman, and we got some infrastructure from steel plant. We had one building which we are partially using. We vacated that, and some 6,000 square feet of area we got it, and we are trying to set up a few labs there. So one of the labs is industrial IoT. For industrial IoT, you know, we will have the sensor testing facilities there. We will have sensors for gas detection. We will have sensors for vibration detection, and any other detection which is required by the industry. So that is one thing. And we are also going to have a robotics lab. You know, robots make life of the especially bigger industries like steel and all easier, little bit easier. So there are some areas where we are thinking to we can put the robots. We'll try to put it. For few areas we have also already identified. So to start with, one of the areas I'll tell you, say SMS, we make steel using this basic oxygen furnace. So when you make steel, in one of the meetings, I had gone to steel SMS. We are observing that they use a lens, and that lens goes inside the converter bath, and after a few usage of the lens, the slag, etc., gets stuck up into the lens, and then it has to be removed manually. Then another lens is used, of course. So what we are thinking, if you can put a robot there, which can precisely clean the lens. So similar applications where we are trying to use our entire technical collective, and we will collect the ideas from them, because they are working in the plant since last 20-25 years. They can give us the ideas which will make their job and life little simpler. So such activities we will take up, And in the maintenance area also, we are thinking to go for, say, predictive maintenance from preventive maintenance. To a large extent, we do predictive maintenance, because if the equipment is required by the maintenance man today, as per the schedule, he's not getting it usually. He gets it when the equipment is available and it is not in use in production and it is not okay. So if you have if you can predict when probably the machines are going to fail from the vibration patterns of the moving equipments, we can go for a predictive maintenance or preventive maintenance. So with such things in mind, we have gone for these 3 labs, say IoT lab, a drone lab also we are planning. Drones, the places which we cannot reach, for example, we have kilometers of gas pipelines. Okay, they carry our process gases like coke oven gas, blast furnace gas, gases from steel melt shop, and we reuse them in our power plants and other places for a variety of things, because they have a lot of calorific value. So these gas pipelines over a period of time, they corrode. And if we want to detect the gas leakage, probably we can use a drone with a IoT sensor, which can sense the type of gas leakage which is there. So that will make the job of the inspection engineer and safety engineer little comfortable. Means they will be assisted by machines which probably have not come much into use presently in the plant. So we expect, and secondly is government is planning for Atmanirbhar Bharat, and everything should be probably, most of the things we should try to make in India with the available capabilities. So we are also trying to encourage the startups. The startups, we are thinking to at least have 50 startups over a period of 5 years. So we are kind enough from STPI, who has come forward and they are planning to be associated with us, so that what will happen, they will also arrange startups who will be doing these jobs. They have the ecosystem with the startups, and we have the industry, and I think so both working together, and with Government of India and Government of AP, we have APIS and other agencies, CII is there, everybody can come together and make a product. Once we develop the product with the help of startups, we feel the cost of the product also will be low. At the same time, because this is a new technology area, we are also trying to rope in our friends, friends who are involved in the automation industry, like ABB, SMS India, Daniel Automation, and few more companies like Polworth and other companies, who wants to come and get associated with us in preparing the lab and making the things, so that what happens now, it's win-win for everybody. And the ecosystem develops in India, and more particularly in Visakhapatnam. And Visakhapatnam is a place which is studded with heavy industries. I will tell you, it is studded with heavy industries. Okay, we have a big steel plant, we have a power plant nearby. We have 2 power plants, in fact, one in the private sector, one in the public sector. We have the power plant from NTPC. We have a power plant from this Hindujaz. We have got 2 power plants. Then we have got a lot of chemical industries like HPCL and other downstream units. We have a pharmaceutical unit which has come up. Like that, we have got a lot of industries. So once the ecosystem develops, they will also start getting benefited. Basically, it will be probably a win-win situation for everybody. So this is what we are planning, and we hope to see good days for say, startups all across India. And as an industry big brother, our chairman is going to be the chief mentor for this COE. And obviously, under his able guidance, we feel we will be able to do something and make products for Industry 4.0, which probably we were not thinking that such products can be produced, or if we wanted something, we used to import from say other countries who are making it. So this is what briefly probably I wanted to tell, though my time has not come. But other things, if you want me to tell who are probably our partners, we have got Ministry of Electronics and Information Technology, Government of India. We have Government of Andhra Pradesh, STPA, Software Technology Park of India. Then we ourselves RINL. Then we are also working in universities like Andhra University, Uttar Pradesh Innovation Society, okay, because we require student startups. So we require Andhra University, institutes who wants to come up with their startups. We want to help them. Then we also have in partnership with Indian Confederation of Indian Industry. They will provide the platform for us in national and international societies. Even Computer Society of India, also we are trying to have a partnership with. So
Thank you. Okay,
yeah.
let me welcome.
Sorry, Nirmalo have joined.
Yeah. Thank you, Subratada. Very good afternoon to you, Shobhachachida.
Good afternoon.
Very good morning to you. So both our organizing committee chairman and secretary are both here with us. Ankit, it's exactly 4 o'clock, so we can get started. Mr. Biswal, we'll come back to you with your turn. And in the meantime,
Okay, should I mute it?
You can keep it muted, no problem. You can keep it muted, so there's no feedback. Ankit, let us start because it's exactly 4 o'clock by my watch. You can get started.
Okay, so warm welcome to all the panelists and attendees who have joined us today. Our topic for today's webinar is Industry 4.0, Digitalization in the Steel Industry in the New Normal Era. So to give a brief introduction about today's topic, I would like to play a small video made by World Steel Association. So I'll just share my screen, and is my screen visible to everyone?
Yes, it is.
Yes.
Okay.
The Industrial Revolution began with mechanization and the invention of steam power, which fundamentally changed manufacturing. The second leap forward introduced assembly lines, mass production, and electric power. Technological advancement then ushered in the third industrial age, where computers and automated machine processes streamlined and improved the efficiency of the assembly line. Industry 4.0 builds on this computerized process through the use of sophisticated artificial intelligence systems to ensure optimum efficiency. The steel industry is leading the way in augmenting and improving processes through every part of the steel life cycle. Smart production techniques allow steel producers to seize the opportunities presented by the fourth industrial revolution. Several steel manufacturers are developing near-autonomous steel works where people, products, and production facilities are fully connected. Sensors collect vast amounts of data across the production facility, which is then interpreted by AI. This optimizes the production line and the operations and temperature of the furnace, creating valuable synergies. The round-the-clock nature of modern steelworks means sections of the factory are not always in use, but during this time energy is still consumed. Smart factories can self-generate electricity using the gas from their furnaces and rolling processes, but are still reliant on grid power. There are ways to improve this further, with smart meters and other sensors cutting CO2 emissions and reducing energy waste. Industry 4.0's rich data also improves safety, with some steel manufacturers aiming to predict hazardous situations before they occur to create a zero-accident workplace. Engineers can be equipped with smart hard hats mounted with cameras, hazardous gas sensors, accelerometers, and positioning technology that can warn them if they enter an area of the factory that requires greater care. Industry 4.0 heralds an era of safer, more efficient, and more sustainable manufacturing, and steel will be at its forefront.
Great, Ankit.
Yeah.
In the history of industry, there have been many revolutions.
Yeah, so that was just a brief introduction of how Industry 4.0 can affect the steel industry. So before we begin with our webinar, I would like to take a moment to welcome our sponsor, SMS Group. We thank them wholeheartedly for supporting our event. A warm welcome to all our panelists, the chairman of our organizing committee, Mr. Subroto Mitra, ex-joint managing director, MN Dastur & Co. Limited, and our organizing Mr. Shobhashachi Bandopadhyay, CTO, Big River Steel, USA. Now, as the session progresses, we expect the attendees to naturally have some questions for the panelists. So for that, we have a Q&A section in Zoom, which can be accessed by all the panelists and the attendees alike. So I would request the attendees to post your questions and queries in the Q&A section, which will be visible to all the panelists who can choose either to answer it live or directly in the Q&A section. I would also request all panelists to adhere to the time limit of 8 minutes as per the program to avoid any delays. Now I will introduce our panelists for today.
Right. Yeah.
So is my screen visible?
Now,
Ankit, can we mute all
not
the
diplomatic. We are doing dynamic. No, no, no.
all the speakers
No, no,
other
dynamic
than
limits.
that you are
Dynamic limits.
speaking?
There, the maximum work is happening on dynamic.
Yeah. Okay. Perfect.
Thank
So
you.
yeah. Okay. Is my screen visible to everyone?
Yes.
Yes, it is.
So our panelists for today, Chairman of our organizing committee, Mr. Subroto Mitra, ex-joint Managing Director, MN Dastur & Co. Limited. Mr. Shobhashachi Bandopadhyay, CTO, Big River Steel, USA. Our keynote speaker for today, Mr. MP Dubey, Joint Director, Software Technology, Parks of India, Ministry of Electronics and IT, Government of India, and Nodal Officer, Andhra Pradesh, IBPS. Mr. Ravi Singh, CEO of Sult Bahrain. Mr. Alessandro Ardesi, CEO and member of Board of Directors of Danelli Automation SPA. Mr. Saurav K. Ganeriwal, Chief Digital Officer, Jindal Steel and Power Limited. Mr. Manish Bhatt, Digital Sales and Marketing, SMS India Private Limited. Mr. Ashok Nath Biswal, DGM, IT and ERP, RINL, Visakhapatnam Steel Plant. Mr. Minesh Mohile, AVP Information Technology, JSW Steel Limited. Mr. Ramchandra Chakraborty, Managing Director, PSI Metals India Private Limited. Mr. Rohit Gupta, Head of Sales, Transport, Logistics, Metals and Mining, L&T Next. Mr. Kalyan Ram, MD and CEO, Electrono Solutions Private Limited, Bangalore. Mr. Devojyoti Roy, Principal Executive Officer, Tata Steel BSL. Mr. Praveen Casey, Digital Solution Architect of Metals, ABB. So thank you all for joining us today, and thank you SMS Group for their support. So our moderator for today's discussion will be my father, Mr. Nirmalia Mukherjee, who is the editor, Steel and Metallurgy. I would request Mr. Subroto Mitra, the chairman of our organizing committee, to now take over from here with his welcome address.
Thank you, Ankit. Thank you, Nirmalo, and other participants and eminent speakers. Good morning to outstation European and American attendees, and good afternoon to Indians. It's really interesting. Once again, we have assembled here to share our thoughts. It's really interesting. As Ankit showed in the video, Industry 1 started with a great steam industrial revolution in Great Britain. Steam transformed the world. In our lifetime, then came the electrics. In our lifetime, we have not seen Industry 1 and 2, but Industry 3 and transformation, most of us, Industry 3, of course, we saw, and the transformation we are seeing that is coming up is really a great experience mostly for the youngsters and for experienced people. I want to just tell you, when we were working in designing steel plants and working there, we used to rely on, in the Industry 3 portion, where a lot of things happened, of course, transformation to internet, initial stages of internet. In fact, Jumbo Jet 747 is thought to be one of the greatest marvels of modern engineering. That's, of course, mechanical. Then transistor use. We were relying on measurement, site measurement of utilization of gases and fuels and water and everything. Site measurement and SCADA systems we are relying. Now, what we understand now, it's Industry 4 is in the process, that SCADA sort of concept, measurements are controlled online. So what this development will really enormously help the industry, steel industry being industry of industries, everywhere, steel industry has everything. So all the consumption norms, and for a better business, for utilization of the raw materials, everything is measured and rectification is done online. Today we know in one of projects abroad, where even the operation and maintenance is carried on from Europe, because the people cannot go there. And it's not required also because of bad situation it's a North African country. So things are managed from Europe with visual cameras which translates 1:1 image. So I don't want to take more time because I'm let the experts and the panelists who are directly involved share their thoughts, and this will be a great boon to the industry, steel industry in particular, and all other industries. So thank you very much, all the panelists. We await your sharing of the knowledge for the help of the Indian steel industry. Thank you.
Thank you, Subrata, for a very good welcome address and highlighting the transformation from industry 3.0 to 4.0. When I also started in the steel industry, we were just talking about 3.0. We were talking about automation. We were talking about level 1 to level 2, level 2 to level 3, and level 4. Now we have moved much beyond that. Now we are talking about IoT. We are talking about machine learning. We are talking about cloud computing as a part of Industry 4.0. So without wasting much of time, we have two special speakers today who have done it and implemented in their plants. One is Mr. Sabyasachi Bandyopadhyay, CTO of Big River Steel in Arkansas, and the other is my good friend Ravi Singh, CEO of Tul Bin Bahrain. So both Dada and Ravida both will talk about their practical implementation. So without further delay, may I request our organizing secretary for today, Mr. Sabyasachi Bandyopadhyay, CTO Big River Steel Arkansas, USA, to highlight us what their thought on Industry 4.0 is and how they're implementing it in their plants. Over to you, Sabyasachi.
Thank you, Nirmala. Once again, good afternoon to my friends and in India and all the panelists sitting in India. Ravi, you are also good afternoon. All right, 1.5 hours. People in Europe, still good morning. And obviously I'm sitting here in US. Nirmala, thank you very much for at least putting me in the role that you have put me in. I don't know what I did, but anyway, I certainly can vouch for a few things. So first of all, in fact, Ravi and I started with Steel Authority of India Limited in the same year. Didn't know each other that well that time, but now we are getting to know each other. And Ravi can vouch for what I'm going to say. 1990, alloy steels plant where I joined. It's a 1961 generation plant. Some of the facilities were also brought in around 1965. So let's say the latest was 1965, except for the secondary refining units, the little furnace and the vacuum degassers. The furnaces were those. I literally played with the joysticks to run the furnace. So I was inducted as a melter in the electric arc furnace, produced all kinds of special steels. But data was there. We used data, but we used data, what is called thick data. That means the human brain. Now, when I came in, it was almost 80 to 90% brawn and 10 to 20% brain. Why brawn? Because if I don't get dirty after my work, my shift work, then I didn't do anything. If I'm not sweaty, if I'm not stinky, I didn't work. So that means the measure of somebody's work was by the amount of sweat, amount of dirt, amount of grease that was on the shirts and the pants. Today's youth, I don't think would even get there. My son, I can talk about my son. He is very technology savvy. He is a video gamer. He doesn't like to do that. He doesn't like to go to the steel industry, which is so much of dirt and noise and pollution and this and that. So what's our weakness then? If the industry has to go towards that level, take that leap, then it has to also take up certain things that is coming in its way, the change. Now, generally, the industry has been, we have a lot of concept about change management. In my opinion, change management is nothing but being the laggards. The industry needs to do change leadership. So lead the way, not lag the way. Unfortunately, if you talk about 1.0, 2.0, 3.0, or 4.0, steel industry has always been the lagger. So there are other manufacturing sectors who have really gone into 4.0, and you talk about, Subhrata was talking about the jumbo jet. All these aircrafts, they have all kinds of information that is leading to wisdom. So data to information, to knowledge, to wisdom, so that they can easily determine when to ground it, how much should be in flight, which sensor is going bad, or which information is giving us a signal that we need to do something different. In the steel industry itself, we have a lot of weaknesses, lots. It starts with people. We are not able to attract real good talent. How many of the so-called, I mean, I have gone through the Indian education system. So how many of the people, the parents that tell them, okay, your target should be to go and perform well in the steel industry, join the steel industry. They talk about engineering, but to them, engineering is white collar, either a computer scientist, computer engineer, or electronic engineer, something that has to do with, because even the subjects or the courses or the trades are selected based on their ranks. So if you rank well, how many of the toppers are actually pursuing metallurgy or material science or hardcore engineering per se? That's a first and foremost weakness, getting talent. Second, even though we got talent, Ravi knows how many of our peers left and joined the computer buzz that was happening around that time. A lot of our peers actually are in the software industry of today, and they're either metallurgists or mechanical engineers or electrical engineers. It doesn't matter. Then the next buzz is MBA. So do your engineering, go to MBA, and then become an advisor, some sort of a business advisor somewhere. How many people, core engineers, are coming through? And in the process industry, this is a major, major drawback. So what happens? So-called people who come in, they're by default, not by design. So that's the first weakness. How to change that? We have to change the face of the industry. That this industry is really, really tech savvy. So at Big River Steel, we say we are a technology company that happens to make steel. So that's our motto. We have changed the culture. We have a culture of being rebels. So we challenge the status quo. What else is there? I said hard work. Subhrata talked about smart work. So smart work is needed. I mean, you can operate from anywhere. If we are talking to each other, sitting across, multiple seas, oceans, we can even operate our equipment just like that. We have proved that point. Some of the very specific weaknesses, and Ravi is in the heart of it because he's running an operations. Yield loss. What's the value of yield loss? 1%. I can tell you very straightforward maths. It's $3 per ton given $300 raw material cost into the furnace. Very straightforward. How much of yield loss is there when we handle raw materials, fines, generation? There is another series of webinars that Nirmaldo is doing, waste to wealth. Uptime, mill uptime, sweating the assets. We have no knowledge. We run like blinds, either blinds or we have a schedule. Every week, we must go down for 6 hours. That's the way we have done it. No, that's ruthlessly wrong, ruthlessly wrong. Non-conformance, I'll give you some numbers and it will probably generate some thought. If we are producing 1 billion tons of steel, we generate about 6 to 7% non-conforming material. That's about 60 to 70 million tons of steel. And I know what I'm going to say, it will probably hit a lot of the other people who are involved in this business, but to the entire steel industry, that's about a loss of 9 to 10 billion dollars, if not more, just in material value, 9 to 10 billion dollars. Can you imagine? Just imagine on a 1 billion ton production, it's 9 to 10 billion dollars of wasted opportunity for the steelmakers. There are lots to cover. I can go on talking. I think I would rather have people talk about it. I am very excited. I'm very energetic about it. You know, for me, who started with 90% brawn, 10% brain, a computer illiterate till 2004, purely computer illiterate, and now managing the entire digitalization, digital transformation initiative, operations technology, leading a bunch of geeks. That's what they're called, geeks. You know, now at my life, almost at the end of 30 years in steel industry, it has been a different story for me. So Nirmalia, I hand it over to you. I wish people contribute very effectively to the cause, and we have a collective approach to change the steel industry's face in a different way. Thank you, all the best.
Thank you so much, Achira. You are a motivator and you've remained a motivator all through. And you have motivated, I would say, my life completely over the last few months that I have been interacting with you. Let me accept that in all humility. And because of you, I have kept the fire going. And so, you know, there are certain debts you can never repay. You know, old acquaintances, associates who become so close to you at one point of time, you realize their contribution in not only your life, but to take the other lives forward. Having said that, let me tell you, there were 3 gentlemen who came forward and said, this is something you should have done, and we have done a lot on this. One was Ravi, the other was Sobosachida, and third was my son Ankit. So 3 of them, you know, they were jumping out with joy when the moment I decided to go ahead with the digitalization drive. Now let me just take away 30 seconds from you to just tell you one thing. Last couple of days when I was talking to various steel plants about their digitization efforts, I won't name the plant, but a few of the plants said, "वो क्या है? What is digitization?" मैंने तो इतना साल मेटलर्जी पढ़ा है, कभी सुना ही नहीं. I've never heard of something called Industry 4.0. What is this that you're talking about? It's like rocket science for them. So having said that, I'll now move on to the gentleman responsible for pushing the digitization drive in India. I mean, to a major extent in Andhra Pradesh as well. He is Mr. MP Dubey, Joint Director, Software Technology Parks of India under Ministry of Electronics and IT, Government of India. And he is also the nodal officer for Andhra Pradesh IBPS. Over to you, Mr. MP Dubey. Mr. Dubey, can you hear us? Dubeji, yeah, Dubeji, I think you're muted.
Do you able to hear me?
Yes, Dubeji, we can hear you clearly, loud and clear.
Yes,
you are the keynote. You are the keynote speaker. You are driving us from today.
Yeah, basically, thank you very much for inviting me. And I heard the earlier lecture. I think very nice talks where you have organized. And my point of view, Industry 4.2 play a very vital role for the as a steel industry as a whole. And you must be knowing that we are going to setting up India's first center of excellence on Industry 4.0, where we are developing the new R&D on industrial robots, industrial drone, industrial 3D print, and industrial IoT, AI, and other emerging technology. So I will like to show you the presentation because I have 15 minutes time.
Yes, sir, you have enough time. You are the keynote speaker. Even if I take 30, we will gladly take it. Because
I
we
will
want
just
to
like to show you the kind of technology which are coming.
Yes, sir. You have to use the share screen option. If you
Yes,
want
yes.
to.
Yeah, I will do it. This one. I think it is visible to all of you.
Yes.
Yes, sir.
Now already my earlier speaker already talked about industrial 1, 2, 3. Now we are in 4, and a lot of competition also started now. Everybody think of how the price of steel could be reduced, how the productivity could be increased. So technology is only the solution through which we can do it. And that's how the industrial 4.0 digitalization come is basically digitalization of your whatever the practice you are doing, convert into digital transformation. So there is a paradigm shift in the way of industry sourcing, produce, market, sell, and provide support and services. The digital capabilities need alignment toward the organization goal, where we have a internal as well as external. Internal is process and value chain structure, people and culture, and external is your customer, supply chain, direct customer, and end customer. Now I would like to show you some of the areas through which I think almost all people are who are seeing in domain specific in steel industry. You are the expert, but I am in the digitalization age, digitalization area for over more than 25 years experience. So that's why both I will try to show you the way the technology is coming. So there is an emerging technology come now to overcome, because steel industry, some of the countries which are selling the steel like any price. Now how across the world the price of the steel could be bring down and new kind of product could be come out from the steel plant. So that's why the emerging technology which are using nowadays are machine learning, deep learning, AI, data analytics, drone, robotics, IoT, blockchain, 3D, and we try to put almost all things in the steel industry so that our productivity as well as the selling power will be increased. So let us see how the technology is changing nowadays. There's the 10 most innovative technology which are coming in the world. It is through the World Economic Forum, is AR, VR, and other kind of technologies. So now I will talk about the government of India. Also during the budget 2020, yes, they have given more emphasis, focus on analytics, machine learning, AI, healthcare, and other sectors also, because they have talked about healthcare. That's why I brought the government of India also putting more effort on AI and ML and other kind of things, so that more and more productivity will become. In Visakhapatnam, we have one of the highest, the biggest 3D printer in Asia. We can print 2 meter by 2 meter model, and now it is again growing. So that's how the ecosystem is there. And mixed reality, virtual reality, over the period of time, it is a requirement for the steel industry to show your customer what type of the equipment, what type of the product you are supplying directly through the AR/VR. So there are AR/VR plays a very vital role. The second approach of the technology is the cloud computing, through which maximum data you can utilize. So suppose some of the production area like car, and you require maximum data. My earlier speaker talked about that. The data is there, but how you can use those data to make it more productive and this. So nowadays, to get more and more benefit, you require a information based intelligent systems. So that's why the The third item which I like to emphasize on you is the artificial intelligence. Artificial intelligence nowadays play very much to your organization to grow the overall productivity. Like you see, this is the steel industry. And this is one of the company who are giving this kind of solution.
Yield strength, tensile strength, and elongation of coils, which can cause lost revenue and reduced profit.
So your maximum area you require AI as a tool to increase your efficiency of the business as well as the other equipment.
So how is artificial intelligence improving product quality at Big River Steel? The product quality AI application, developed by Noodle AI and SMS Digital, addresses YTE using data from across the factory.
So this is one of the area which AI play a very vital role. The another area AI is using in robotics. Some of the places in steel plant you must have seen where you can increase the efficiency, but the human intervention is very limited. So that time robots can play a very vital role. That's why we have set up in Visakhapatnam a industrial AI robotics center. So that's how we can come with a new kind of product where some of the problems you can able to help. The other areas, and the AI market overall is growing in very high. It is growing at a 17.7%. So I request all the steel industry, the giants, they can work on more and more product to come to increase the efficiency overall in the steel industry. So this is how the industry 4.0 works.
Are becoming smaller. Products get to market with less waste, faster, and on time. Even the most manual processes are turning towards automation. Innovations in machine vision, deep learning, and robotics are revolutionizing production lines and supply chains. Our machines now produce vast amounts of big data accessible via the cloud. As machines and the information they produce become linked, new cyber-physical systems will spark a modern-day industrial revolution.
So this is how the technologies are using, and industrial IoT play a very vital role. In overall, you see the plant. The IoT play a very vital role to make your efficiency of the production could increase as much as possible. So there are many examples are there. So I thought few of the things I should brought to your notice, and to overcome that, the government of India has set up there are various schemes were set up by Ministry of Electronics and IT, and one of the thing is we should set up the Center of Excellence, and the Center of Excellence is which is coming in Visakhapatnam is AI/ML, industrial robotics, industrial drone, industrial IoT, industrial 3D printing. But day by day, the 3D printing is going to play a very vital role for the steel industry. Your customer demand will change day by day. They want very fine product from the steel plant. It should come. So day by day, you have glass furnace and other, but when the raw material come, you can directly go and print it. So that's the thing I will like to show you. The whole process is going to change. What earlier to increase the efficiency, what earlier you used to do in metallurgy and other areas, the whole process will change when we implement the industry 4.0. Some of the problems we have identified within the with the Visakhapatnam steel plant, where the conventional and how those conventional can be converted into a 4.0 application. Like the last one, industry 4.0 based solution to prevent hot metal pouring outside converter, and this will save lot of damage and production and loss. So some of the problems you have now were conventional problems. What we are using, we are playing a very vital role, bringing the best of the talent in India to come and solve the problems which is already earlier to convert into a industry 4.0. Similar kind of thing, Industry 4.1 based solution to prevent steel pouring outside emergency container. This will save a lot of damage and production loss. And we are also some of the, you may able to see gas leakage inspection using IoT device. So overall plant, if you see, that's why we have minimized some of the problems we will find out and try to implement through the Industry 4.2 application. That's how our productivity and growth will be much faster, and acceptability also. So some of the problems you must be saying: human movement detection and oxygen level detection in the bunker using IoT drone during the maintenance of the bunker. So these are the problems basically. We are solving those problems through the startup, the young innovators or the young minds or the experienced people also trying, and Government of India is giving funding to those people also. We are giving 25 lakhs as a seed funding. So like another problem is that BSP maintains kilometer of outdoor piping carrying various gases like an N2, CO gas, blast furnace gas, LD gas. It is a difficult task to detect pipeline wear out and leakage. An Industry 4.0 based solution to detect wear out of pipelines and leakage of gases is to be developed based on this. So some of the problems, existing problem, we are converting into that. Now I am talking about the Center of Excellence, which the Government of India is setting up here. We are coming with, we have a partner already, SMS, and Daniel is our power partner in this process. And I request all of you can be partner in this Center of Excellence, either as a partner, industry partner, or as a mentor, because we need a lot of mentors who are expert on this area and they can help the young talent. So if you see, this is the COE on Industry 4.0. We name this as a smart UPU, and you see nowadays this kind of application we are developing, and this is basically metallurgy people can very fastly, it can be immediately scanned and throw out the dust and other kind of things. This is a small example I'm showing. And another areas, I think this is a very big facility we are coming out, but I will like to show you some of the things we are come with IoT lab. And now this lab, you sitting in Germany and you able to through the technology, it is the IoT, industrial IoT and 5G network, you able to do the work in South Korea, or either sitting in India, you can do work for US companies. So the technologies are coming nowadays. Why not we implement those kind of things to increase the productivity? So that's require the implementation of Industry 4.0. The another lab we are setting up is robotics. You see, we have a very good ecosystem developed by Government of India for the robotics. These are the arm robot arm. Now you don't require a full level of robots when you go for any industrial kind of thing. You require only two hands. So one hand you can see here and another hand. So that's how you can do it. Just I will show this one so that you can know very easily. This is how a chair can easily be done through the two arm robots, and similar kind of things. A complex work also can be done, though it doesn't require a full-fledged robot, a human robot, rather than two hand can work together to make you the solution much faster and much effective. So this is the Industry 4.0, we are systemizing what kind of applications are required, what type of equipment is required to more and more increase of the production. And another thing, what Visakhapatnam is very good in robotics, basically hand robots. We are developing here. You must be seeing this called surgical robots. We are developing these robots for a high-end surgery, cardiac surgery and other. And similar thing we are using now. This is one product which is launching, is called orthopedic through hand robots, physiotherapist. So the orthopedic doctors are using. So how the technologies are changing, including in the health sector also. So steel is also one of the area where we can use more and more the industrial robot to increase the production. The other area is we are implementing is industrial drone. If you see, drone is play a very vital role. It's in the steel yard and try to tag it and make your inventory properly. So we for the Visakhapatnam steel plant, we have find out some of the problems which we can solve through the Industry 4.0 drone system. The another area which we have 3D printing. Day by day, what happen? You're the whole such a big plant system which earlier when the finishing product come, it is now coming reducing and reducing because of the more and more 3D printing. Straight from blast furnace, when your the raw EA is coming, it can directly go to the printer as a raw material and you can print it directly. So this is the 3D printing center in Visakhapatnam. It is the one, and I will like to show you one of the area. This is one of the place I am showing you. It's directly the printing is happening through the 3D printer, and the finished product is coming. So think on that way. The whole production systems are also going to change. So 3D printing play a very vital role. With this, I thought we have many startups which have come working from the Visakhapatnam on these areas, and Industry 4.0, if we make it from the conventional to the digital transformation, it will make a very success venture for the steel industry, and overall the pricing of steel will reduce and you can come with a very good product also, finished product. So the government of India's Digital India mission and the current Atmanirbhar Bharat will play a very vital role in center of excellence which we have created in Visakhapatnam, especially for Industry 4.0, to make India successful on generating new product on Industry 4.2. Thank you very much.
Thank you so much, Mr. Dubey. I was never aware that actually, the software technology part of India under the leadership of our Honorable Prime Minister has contributed so much and gone, especially talking about you, I must thank you from the core of my heart, because you have gone into the depth of the subject in steel industry. You are not from the steel industry, but in spite of not being a part of steel industry, you have gone into the depth of the subject. Now, without wasting much of time, I would like to leave the floor for some questions, which I'm sure quite few would be. Somochachita, Ravi, all of you, and also Daneli and SMS, both of whom Mr. Dubey mentioned particularly. So all of you, I'm sure, will be having some questions. Ankit, if you could just handle the Q&A and put it up to Mr. Dubey.
So, yeah, Mr. Bandyopadhyay. Yeah.
Yeah, so first of all, Dubeji, thank you so much for giving an insightful message. And I'm excited to hear that there is a center of excellence coming in. And I think you rightly pointed out that you need that center of excellence would certainly need mentors. And
yes.
Because, in fact, in my current role, I'm basically the mentor for the team because I'm not a software engineer. I'm not a programmer, but I know the steel industry. I've worked in the steel industry hands-on, and so you are absolutely right that to make it really successful, you need industry involvement and industry stalwarts to come in and provide that experience, which is not burdened by experience itself. It is in fact encouraged through exposure. One thing that I was really taken aback that you mentioned Big River Steel, and you have taken that little slice of the video that we have been publishing to the world. And yes, so in fact, the goal, Mr. Dubey, in that is to create a biometric. You know, when we go through the airports, we have our biometrics, so fingerprints. So once we have those fingerprints, the Department of Homeland Security, they know everything about us through those fingerprints. So similarly, the steel is generally, it is tested only on certain locations. But if we have a biometric of the entire steel coil or a sheet or the bar, however form it is, so the users would know what exactly the property variability, the variations, the nature of the entire steel surface, every point, it would be well known to them. So, and they can modify their process accordingly. Again, it can be a closed loop system. So everything, the way the things should work, and when you are working on your excellence, Center for Excellence, please keep this in mind that the focus should be on closed loop system, how we can close the thing so that the decisions are quick, so that wastage, because spiritual wastage, decision making delay is one of the biggest drawback in the industry itself.
Yeah,
So thank you very much for your encouraging talk. And
but sir, I need more and more mentors. If you could agree to be a mentor for our CEO, I will be very happy.
Absolutely. My contacts are there with Nirmallo. I would love to have your contact and be in touch. And in any shape or form or fashion, if I can be of help, by all means, absolutely. I would love to do that.
So through this webinar, I also request all the people who are listening, including the young generation, you should think Atmanirbhar Bharat. Come before us as a mentor, because you are the domain specific people and we are the digital people. When the domain specific innovation happen, both digital as well as the domain specific people, when join together, then the success will come. And through that we can bring a very new product also. And SMS, I think, is already a industry partner with us. Daniel is also industry partner. Others are also joining in this Center of Excellence. We want best of the talent to come and innovate Industry 4.0. That is the basic idea.
So Dubeji, how many people are you recruiting for the start, or have you already recruited?
Already there are 30 startups are working, and we have planned this year to increase to 300 startups.
So this Center of Excellence, you have researchers or young talents
Yes.
actually working on. So how many of those are there right now?
Those are around 20 people.
Okay. And these 20 people are involved in multiple projects. Those are the startups that they are
Yes.
involved with, or they are funded by the industry, or they are associated with universities.
These
how
are all
they?
funded by the government. We are bringing industry universities also into this, because industry, academia, as well as linkage should be there to more and more what I'm saying, research oriented products should come out. So we are now tying up with some of the universities also.
And this is the first one of its kind, I believe, as you
Yes.
said. So are you also thinking about putting nodal centers in other steel centric cities or places?
Yes. First, this is the main center. We will run on a hub and spoke model. So this will be the hub across India. This is the center of excellence, because a lot of investment we have made on that. And the other places we will make as a spoke model. There we will create in a very smaller manner, and finally that can become in a hub.
Bhushajita, I have a suggestion here. Since just like Waste to Wealth, we are doing a series. I think we will take the help of Dubeji to have a series on Industry 4.0 and digitalization,
Yes.
and taking various aspects into account. One we can do only on logistics. One we can do primarily on iron and steel making part. Then we could move to other areas as well. So taking the entire ecosystem in mind, I think we should do the entire series. Since you are the organizing secretary and Subratoda as chairman, I would like to propose to the committee that we have, just like Waste to Wealth, we should have a series. I think you will agree with me on this, and I'm sure Dubeji will guide us in these entire series together. What are your
Yeah,
views?
that is a good idea, and that through that only we can increase the Industry 4.2 penetration in the country.
Yeah, Manish, would
That's
you like
music to mind.
Yeah, that's for sure. So it is accepted.
Absolutely. Until unless Subrat.
Perfect. Manish, since Mr. Dubey also mentioned about SMS and Dhaneli, so as the head of sales of SMS Digital India, what is your question to Mr. Dubey?
I think some of the ideas he has mentioned are really, let's say, effective. So, I mean, the only question is when we can talk and discuss this in details.
That is why I suggested a series. We are going to have series, and then whenever physical distancing is done away with, we will have a one-on-one meeting in Vizag itself. But till then,
one thing I forgot to mention: the CMD RINL is the chief mentor for this whole project. Under his leadership, the Industry 4.2 is running now. Because we need that kind of people as a mentor who can run this show.
Right, Ardesi, your question now. Your company was also mentioned by Mr. Dubey. So, Ardesi, your question: what kind of support that you would extend to Government of India, Ministry of IT, to move this forward?
Okay, I think that we should go deeper in what are the things that have been shown during the interesting things that have been shown during the presentation. Some of that field of research we are already involved, so it could be nice to understand what can be put together in order to see if there are space for partnership or for support. I suggest to have a dedicated meeting. It is better to have a dedicated meeting directly with our guys in Dhaneli, India, so we can shorten up.
We are already in touch with them.
Yeah, with also with the Dhaneli India automation, in which we have several very skilled colleagues, and we can coordinate together in order to see what can be done.
Mr. Ardesi. Ramda, do you have a question? Then we will move on to Ravi, and I think there are some questions from the audience also. Ramda, do you have a question? You have to unmute.
Yeah, this is a very good approach. I believe there's industry and academia come together and do, many good things for the Indian steel industry. That's very much required. There's a welcome move.
Thank you, Ramda. Ravi?
Yeah, I would suggest if Mr. Dubey can take this suggestion from me to interact with AICTE, because this is the new technology. This is the world today in Industry 4.0 is where computerization was there in 1980s. And any country which took the first step forward in that has become the world leader. So it'll be very nice if Dubey Saab interacts with AICTE, and it'd be wonderful if you can influence them to have one unit during the 64 units of engineering on Industry 4.0, maybe in the first and second year, which are normally common years, and teach the new budding engineers about what is Industry 4.0, so that when they come out with their degrees, they are not living in the old world of theory, but they also know new ways of approaching the problem. And that, I think, would be very good for taking the entire country forward. And of course, it would be, it's always possible for you to interact with the various industries and help them to move forward, take their help also in this process. But I think if you have this, your department's linkage with the industry curriculum, you could really seed the ideas in the young brains. That would lead to a transformation in the country.
Yeah, Ankit, let's put on.
It's a very good suggestion.
Yeah,
I think
let's
we'll
put on. Dubeji, let's take a few questions from the academia side also. Professor Argham Majumdar, are you there? Ankit, can you see Professor? Yeah. Professor Majumdar, your question, please.
Good afternoon. Am I audible to you?
Yeah. Professor Argham Majumdar is director at Kaji Nazrul University, which is located at Asansol. It's a new university where, he was earlier, by the way, he was earlier in Vizag Steel Plant. So he's an ex. So
yes. Till March, I was there in Vizag Steel. Yes. Till March this year, I was there in Vizag Steel. So for me to speak from the university side, it is a real opportunity because I have joined here as director School of Mines and Metallurgy, where we are starting a data science on MSc on data science. And another thing is that what we want is that can we make a collaboration with you so that the mines and metallurgy and the data science can be come together, and it from the university side, if we are given a chance to have a MOU with you, so the students nearby this area, I am from Asansol, so the Asansol, Durgapur, this is an industrial belt of total West Bengal.
Yes.
So the people will be getting benefited for this. So what are the ways to have a collaboration with you guys, and it will help the university as well as your side also. So can you throw some light on it?
Is this a government university?
State government. Yes, it's a state government university.
Then there is no problem. We can sign the MOU. And this is one of the good, I think you have taken on data science, on material sciences. And it requires huge material science. And now you must have known that
Yes.
here also we are setting up one cloud on that. So over the period of time, as much as the computers are going powerful and powerful, more and more data and the IoT will work about the. So this is a very good step. We can go with the MOU. There is no problem.
So what are the procedure? Can you just tell me? And think
You
in
can
fact,
send me a
after
mail.
this new normal situation, this has been.
We can do it.
We can do it. Okay. So can
You can
just
send me a mail at dubey@stpi.in.
Okay. That I will try to contact. And
yeah, I also have Dubeji's contact with me, so I can share it with you.
Thank you. It will be nice help to you.
Yeah. Thank you. Ankit, any other question from the audience?
Yeah, so we have another question from Mr. Patra. Mr. Patra, you can just introduce yourself and ask your question.
Yes, good evening to all. My question is for Mr. Dubey. And it was really fascinating because I recently retired from JSW Steel Dolvi. Before that, I was associated with your Center of Excellence, a few other, IIT, Mumbai, Kharagpur, and other area. But I was not aware of this particular Center of Excellence, hijack. But you know that all the steel plants, even in JSW also, there are a lot of initiative for digitalization. And I was also involved in some of those activities. But I have never heard of this Center of Excellence, Visakhapatnam. So that was my one of the question, that how you are connected with the other steel plants. I know that RINL is one of the mentor, but I mean
Chief
there is
mentor is RINL.
okay, but
Other steel plant, this is the thing. That's why I request other steel plant can also join as an industry partner with us.
I think that they may not be many of may not be knowing. So that I mean both way it is required. I mean this is the
we are going to have a lunch on actually because of this epidemic we are not able to, but honorable ministers we are waiting for their time. So once we get their time, Ministry of Steel and Ministry of IT and our secretaries, then we will go for a lunch of this center.
Because I know, because when we started some of the activities for digitization, so we have struggled to develop. Parties get the thing done. But if we would have aware of this center of excellence, I think we could have taken your help, and that would have been very, very beneficial.
Yes.
Okay, that was only I wanted to share with you. Thank you.
Thank you. Thank you, Patroda. Thank you so much. Ravichandra ji, do you have a question for Mr. Dubey with regard to what Monet, JSW Monet plans to do on this front, or you have any initiatives in mind? Mr. D. Ravichandran.
Yeah. Good evening.
Director with Monet JSW. Yeah.
Thank you. I just entered. I yet to get into this one. I had not heard fully also. Anyway, I'll interact little later. That will be fine. Okay. As such, we are taking up the digital initiative, and I'll come up in the right time for that.
Thank you, Mr. Ravichandran. Ganeriwala ji, you are the Chief Digital Officer of JSPL at Angul. So what is it that you would like to suggest to Mr. Dubey for an interaction between JSPL Angul and with STPI project on Industry 4.0?
It is indeed an honor to have a look at the presentation which Mr. Dubey made, and this was really interesting. And as Mr. Patra mentioned, right, even the awareness of having that COE was not there with us. It's a great initiative, and I think with a lot of startups getting incubated, it actually makes a lot of sense to have very close interaction with the industry problem and solutions specific to the industry problem, because that's where the value is. You can solve them targeted for a domain, and that's how the technology can actually bring a lot of value. So thank you very much for this awareness, and we will connect with you separately to probably see how we can engage and what else can we do with you to make it even more effective and leverage both of our skills together.
You can join as an industry partner with our COE, so that some of the problems we have already highlighted to you, which our startups are working with. The two things I am to this whole panelist who is just sitting there, I request join us as a mentor. Without mentor, the new innovation coming is not so much of practically possible. So I need you people, such a huge experience. You people, please join with us, Government of India, as a mentor, and some of the organization can join as a industry partner, which will help the COE to grow in a big way.
Thank you, Mr. Dubey. Now I would request JSW, Mr. Mohile, who's handling the IT and digitization at JSW, to put in his thoughts with Mr. Dubey.
Mr. Dubey, it was very nice to see the COE. Thank you for showing us what Government of India is doing currently. One important step in bringing the industry and the academia I think we also need to look at quick funding of the entire activity, because without that, only academic activity would not give results. And that is my opinion.
Funding is done by Government of India, sir. The whole
Correct,
funding is done by Government of India.
Correct,
We don't require any fund. We require only mentor.
True, we would be very happy to do that, because
The funding is all full funding is done by Government of India.
correct. That's very nice to hear, actually, because that is something which the innovation world needs in a very important way, especially in our country. And we have been, as Ravichandra Saab said, we have been doing a lot of digitalization at JSW. I will tell all of you what we have been doing in the last 2.5 years, and what is our plan going forward. So a huge world of Industry 4, we are trying to imbibe, trying to change the very culture of the organization and put forward the digitalization initiatives. So we would definitely and certainly like to leverage the COE, and we would be there. Definitely, we would connect with you immediately after this session, sir. Thank you.
Thank you, Ankit. Any offline questions? Any audience questions?
Yes, so we have time to take one more question for Mr. Dubey, but there are a few other open questions in the Q&A section. So I would request Mr. Dubey to just go through it once as the session progresses to answer some of the questions live. So the last question we will be taking will be from Mr. Deepak Jain. Mr. Jain, could you please introduce yourself and ask your question?
Yes, I am Deepak Jain from Bhilai Steel Plant. Are you able to hear me?
Yes.
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 Yeah. So it was very nice to understand and know about the Center of Excellence. And since Dubey sir mentioned that there are around 30 startups already working in this direction. So I wanted to know whether already they have developed some data analytic application based solution for the common maintenance problems faced by steel plants, or is any particular job being done in that direction so that can be benefited and used by our plant also?
Actually, the product is not yet been the startups have come, but product will take at least 6 months time, 3 to 6 months time. But anyhow, if you have any problem, you please send it to us so that we will give it to we will organize one challenge, and if any startup will selected, we will keep in our COE and fund them for that to develop that project. Funding is done by us, and we need mentor like you people who able to know the problem and able to solve tell the problem in your domain knowledge, so that the people will convert that into a digital. That is the basic idea.
Right, sir. Thank you, sir.
Thank you. Well, we'll now move on to our next speaker. Thank you so much, Dubey ji. Please stay with us. आप कुछ देर बने रहिए हमारे साथ. As long as you can. So we'll now
Thank
move
you
on
very
to
much for inviting me to this.
and we will continue with this with your support and guidance for a few more sessions we'll have in series, where we'll identify problems and try to find out solutions for each area. For example, I just got a message right now from SMS Digital that we should have a session only on steel making. Only on the SMS part we'll have the steel melt shop will have a separate session together. So with that, we'll move to the next speaker, who is Mr. Ravi Singh, CEO of Sulb in Bahrain. Now they have 3 plants in Saudi. I mean, total 3 plants, including in Saudi Arabia. Now he was earlier he started with Tata Steel, Tata Ryerson, and then he moved on to SR Steel, and now he is with Sulb as CEO. So over to you, Ravi. The floor is yours.
Thank you, Nirmalyada. I will let me just put together a small presentation so that, and I will be sharing with you my experience on Industry 4.0 and digitization. It not be fully aligned with what others have spoken or will be speaking, because to an extent, this is like an elephant and the blind men. So someone catches the tail and says this elephant is like a snake, and someone catches the body and will say that it is like a wall. I think maybe at least 20 years down the line, we'll come to know what really Industry 4.0 or digitalization is all about. And Subhishachita had already given a very good introduction. So in a way, I'll be taking forward from there. We all know the steel industry imperatives, high capex industry, multi-factor coordinations, human limitations in understanding all, grasping all the factors which are leading to real-time balancing of decisions becomes difficult. High energy cost factor, which is an invisible thing. It's just, you suddenly realize that you're building up losses because of poor energy controls. Profitability needs high capacity utilization because the high capex industry. And then it requires alignment of consumption norms with the theoretical consumption efficiency trends. Marginal cost globally is almost equal to the marginal cost of production. Marginal sales price is equal to marginal cost of production. If you can produce below the marginal cost, global marginal cost, you make money. If you don't, you're going to be losing money. Manpower, especially outside India, I can tell you, is costly in the industry, in the steel sector, compared to what you'll find in the other sectors. And decarbonization, I've deliberately put it because that is the elephant in the room, which is going to change all the technologies in steel going forward, and it is going to have a major technology input. It's good to just look at this, some examples. Recently, an F-16 Ace pilot went into a head-on a fight on a simulator with the Heron system. And the Heron system shot him down 5 times in a row, which basically proves that human mind is no comparison to artificial intelligence system. In fact, it is now agreed that future planes should be actually only flown by pilots, and rest of the job should be left to an AI for automatic fighting and shooting down, etc. Deep Blue defeated Kasparov in 1997, but what is more interesting is what happened in 2017. By the way, nowadays, just like you have chess championships, you also have chess championships among computer programs. And the 2016 winner was a computer program called Stock 5. And then in 2017, there was a computer program called Alpha Zero, which basically challenged the 2016 winner. This 2016 winner, of course, had all the human experience put in, hundreds of years and tons of computer experience in playing games. Alpha Zero, its speed was also very high. As you can see, some millions of chess positions per second it could calculate. Alpha Zero started at a very docile 80,000 calculations per second level. Had no human chess inputs put into it, but it had put in machine learning, which basically means it kept reprogramming itself based on the experience it was getting. The algorithm kept getting changed. And on the day of the playoff, 4 hours before, Alpha Zero started playing with itself. 4 hours. After 4 hours, it went for the test for the championship. And out of 100 games that the two programs played against each other, 72 were draw, 28 were won by Alpha Zero, and Alpha Zero did not lose a single time. This is an example that hundreds of years of human experience, which was actually programmed into the Stock 5 program, failed to help it fighting against an AI intelligence of Alpha Zero. So that's a very sobering thought. This is a typical graphic user interface of a steel plant control room. And this is just one of the 24 screens that you will see. And it reminds me of a famous poem that we used to hear: water, water everywhere, not a drop to drink. It's more like data, data everywhere, not a, how do you make a responsive decision based on this? That is where really Industry 4.0 came up, and it was a process, it was a term that was coined in some computer conference in 2012, and it caught on subsequently. Actually, if you look at a steel plant, when you're buying a steel plant, you start with a process technology selection, which is a very critical part of the selection. After that, you have traditional automation levels. Some of it, the highest level out of that is what I showed in the previous slide. You will have field instruments, you have basic machine level automation through PLC controls, etc. You will have shop level automation through level 2. And then you'll have plant level automation through level 3, where you start looking at integration of all the supply chain elements across the plant. And of course, you can have level 4 on top of it, where you're trying to integrate the market and the planning levels into the operations as well. These are levels which have been under discussion since 1993, 92. In Steel Authority itself, I remember we were discussing this in 1994. So, and the world has more or less been there. It's just been adding on to that. What you do with all this data that we have is basically do the analytics, because you still have constraints in each plant. You still have losses happening in each plant. So when you're looking at Industry 4.0, the next level of digitization, you look at your plant constraints. You look at what are the variances that you are achieving with respect to the basic engineering efficiency curves, efficiency trends. You look at what are the best process improvements that have been achieved globally. And then using that, you basically use a standard technology solution like a Six Sigma, DMAC, and integrate that with real-time digital data sensors. Six Sigma historically, traditionally has been based on certain data collected at some historical point in time. With the 4.0, the way I look at it, we integrate it with online data coming in. And then there are really 4 major elements of this. One would be a big data analytics and AI-based execution. These are algorithmic programs which can take decisions, which can execute decisions based on the data which is feeding into them. And my guess is that 50 to 60% of savings will actually come from these kind of interventions. It's a very important divergence that I'm bringing in over here. The second level of interventions would be in the process of process digitization. Already there's a lot of process digitization each industry steel plant has. In case there is some shortfall, yes, you can go in and do some digitization, extra digitization into the plant operations. And then there are some certain operations which are basically better handled by robots and through automation rather than by human beings. But in a steel plant setting, I think that would be about 20–30%. Typically very dirty, very high temperature jobs, better given off to robots and automation rather than do it themselves. And then of course, there is this concept of new businesses which can be based on the digital platforms, which are still emerging businesses. To an extent, as Sabhichatida said, that steel industry has been a bit of a laggard. Yes, in e-commerce also we are laggard. If you talk to steel plants and say that you can sell steel on a platform, most common feedback is you don't know what you're talking about. But there is some movement which has already started in that front. And I personally would be very happy to see that it becomes a common norm. It will help the steel plants also quite a bit, because the cost of order acquisition would really go down and the cost of order servicing would really go down. So that is what, for me, the last paragraph, this last 4 interventions is what Industry 4.0 is more about. It is not so much about hardware. It is more about using the data which is already getting generated at so many points in our organization and having a very algorithm-based decision makers algorithm which go in and react very quickly so that the variance in our trend consumptions is as good as 0. So the trends are always very close to theoretical trends. To do this, change management in any social system, change management is very, very critical, and especially in organizations like steel plants, which are very large number of people. team is key. The team for this digitization is key. Its commitment as well as its capabilities. Because when you have so much of diverse data coming in, you need to have that. When I'm talking of commitment, I'm talking of an intellectual commitment that yes, the process that I'm following can deliver the results that I'm looking for. And yes, you need to have capabilities of not just knowing about the steel industry, about the metallurgy processes, etc., but you also need a good dose of knowledge of statistics and what are the emerging developments in the areas of sensors and things like that. So a good team leader, a good translator, person who can translate a process problem into a digital problem. He is a very key knowledge resource. And the second would be a data scientist who can convert the data into make some sense out of it at a high level, and then use his data engineers to actually do the correlations and the regressions and convert correlation to causality, which is really very critical, because correlation does not mean anything. Causality means everything. When it is a causality, it becomes a feedback, and that really drives the thing. And as you know, there's a famous tongue-in-cheek remark that lies, lawyers, and statisticians are all the same. That's because there are so many elements in statistics that correlations do not prove causality. So that is a big challenge which this team has to overcome, which means it has to break that myth and lead to a situation where statistics actually can be a source of data, and data then becomes a source of fact-based decision making. As you know, there are a lot of questions on what are facts. Solutions have to be dynamic. They cannot be cut paste. Because each company has its own problems of the kind of material it uses, the kind of methods it uses, the kind of machines it has. So there are limitations of how much you can copy paste a solution from somewhere. You can take help. Yes, if they're very good people like SMS or Danieli or someone else, they would know the extent of their problem, their solution capabilities, and they can tailor it faster than maybe your teams can. But somebody has to do that customization. And ultimately, I always remember that when computers were there, we talked of outsourcing computers. Industry 4.0 is going to be like computerization program. You need to have your own key resources for a sustainable approach in this. If there are additional sensors, one thumb rule is the cost should be kept very low. If the cost, people are coming back and saying that costs are going to be very high, means they are barking up the wrong tree. This is a small map that we have about a vision of Industry 4.0. You'll find it goes in and impacts almost every element of the plant, and that is what is the big thing. That Industry 4.0 is more about management and less really about technological input. You can have any number of success stories. You can have Ariba, you can have SAP Fieldglass. We use Intellex. We have all kinds of programs here and there. And we keep implementing. Our IT team with the operations team keeps going in and looking at how to improve things, how to roll out artificial-based intelligence solutions, and reduce the variance in the plant operations and in the system as a whole. I think that a good area to focus on is maintenance, Google-based technology, so that whenever technicians go near a machine, they immediately get the procedures, they get the safety instructions right on their glasses itself, and they can do a much better job than they would be able to do otherwise. Google-based team management is a big thing. Ultimately, the most important thing is any solution. It can be technically great, but it needs to have a social acceptance, because we're all human beings at the end of the day. And that change proneness in your own employees as well as in the customer is what will really drive the success of this new level of initiatives. Over a period of time, we will all accept it and it will be there. But it is always, as the management has shown, to the first mover advantage, which makes all the difference. Thank you. Be safe.
Thank you, Ravi. Thank you so much. I mean, you made us travel through the entire journey from industry 3.0 to 4.0 and beyond. So it was, I would say a live journey that we went through your entire presentation. And as you rightly pointed out, the acceptance of new technologies always takes time. So it will take a little time before we get into that mindset. But I'm sure with the younger generation taking over in the working of the steel plants, they would be the ones to take this drive forward. So with that, I'll thank you, Ravi, for really giving a wonderful presentation. I would say, Soboda, you, Dada, your great advantage is you always think ahead of time. So both of you are visionaries in real sense of the term, and that is what that is why I keep asking you to help us move the industry forward. So with that, I'll move on to the next presentation by Mr. Alessandro Ardesi, CEO and member of the Board of Directors, Danelli Automation, Italy. Mr. Ardesi, the floor is yours, after which we'll move on to Mr. Saurabh Ganadiwala, Chief Digital Officer of Jindal Steel and Power. So after you finish, you will hand over to Mr. Ganadiwala. The floor is yours, Mr. Ardesi. Ankit, I'm taking a break for 10 minutes.
Okay.
Thank you very much. Good evening to all the attendants, to the colleagues that are panelists. I will start sharing my desktop. I hope that it works. Do you see the presentation?
Yes, we can see.
Okay, perfect. Okay. What I try to show you is in this few minutes is the concept that Daniele has for approach the industry 4.0, giving to our customer that are the metal company at the end, what we think are the right tools to approach the digital transformation. Because as Mr. Ravi said before, it is a matter of fact that the digital transformation is in the hand of the metal company, and what Daniele or SMS or the plan-making companies have to do is to give them the right tools and the right method to implement at the best. From our point of view, we have to think on 3 different dimensions. The Daniele Intelligent Plant can be thought starting from the center, that is the advanced concept of the 3Q pulpit, that is that gives the possibility to have an autonomous process optimization to support the operator with the decision making supported by data and statistics. Then the use of data that are present in our plant since the 80s. The step is to use this data in the right manner and to focus on data and the event to give the right information at the right moment. We have seen before one SCADA screen with a lot of number on it, and the decision with this kind of interface is not so fast if you have a problem. Then the concept is to give the right information at the right moment at the operator, using the data, using the artificial intelligence, using all the information that can be done by the use of the knowledge of the people, put it inside the automation and the industrial IoT. You can see here there are some example of the same concept applied to different kind of process. You can see a seamless pipe mill, a continuous casting machine, and an upstream mill. The concept is the same. The information is the right one that is needed at the moment for the operator to conduct in the right manner that specific stage of the process. Another concept is to concentrate all the conduction in only one point, in which you can see all the complete plant, and you can avoid to have people on the floor. So the concept is to have no man on the floor and to concentrate all the information in one only pulpit to give the possibility to have a fast reaction to any event. Here you can have you can see some example of application in which with a few operators we can control the whole process due to the fact that we are using the information that comes from data and the information that comes from the knowledge of the metal company that is contained inside the automation and the industrial IoT. We will do a step ahead in this direction. In November we will unveil the new concept for the conduction pulpit, in which we will go a step ahead, integrating in addition to the data-driven process control, also a different approach, a different interface between human and machine, with the aid of augmented reality and mixed reality in an industrial way, in a way that can be used for 3 shifts for a day, and in a way that is the translation of the concept of mixed reality into things that can be used in the metal company. Over this layer, for sure, there is insisting on the same base of data and the same data lake that is the container of all the data that comes from the process. There is what we call Q3 intelligence, that is our data analytics, machine learning, and artificial intelligence platform that can help to develop the production monitoring, to detecting the anomalies, and also to keep under control and to optimize the consumption of the energy and media. The third dimension is the collaboration. Then the digital transformation help us to have as today we are talking several thousand kilometers of distances, but we can do the same on the plant. So it is possible to have direct support from a plant of the same group, where expert can support operators that are less skills to solve problem, using a communication platform that we call QSpace One, that is based on augmented reality and connectivity. So in this slide, you can see what is yesterday. When you have a problem, you need to go to the on field. The expert goes there with the drawings, with his knowledge, and needs to move on the specific site to solve the problem. Today, we can support the customer or support our colleagues also, or the colleagues of the metal company can be supported by each other without moving. So by the use of a digital platform that support knowledge sharing, traceability of the activity, and also the direct feedback on the works that have been done. I would like to show you. We are quite short on time, but I would like to show you what is possible to do with this technology. Sorry, but there is a problem here. With the use of this kind of technologies in this situation of problems in moving and due to the COVID restriction, we had the possibility to start up from remote several plants in the last 2 months, without sending our specialists on field, and by the use of a remote connection, we are now as a usual behavior conducting the factory acceptance test without asking the customer to come to our facilities, but giving them the possibility to connect on our own facilities of automation, on their equipment that is under testing in our facilities before the shipment. So the point is the digitalization. It is the way to have a more sustainable business for the metal company, a business that is supported by the knowledge that comes from the metal company, that can be stored in the digital system, and not anymore in the end of the single operators. And the last thing is the possibility and the extended use of collaboration by the means of augmented reality and connectivity tools and collaboration tools. I have finished. Thanks.
Thank you so much, Mr. Adesi. A very exhaustive presentation of Danelli Industry 4.0 portfolio, and as you noticed, Mr. Dubey is also interested to work closely with Danelli and SMS on this front, and I'm sure you will continue to extend your support to the industry, to the steel industry. Whenever we need Danelli and SMS to be there, you will be there. The three big darlings are the ones we need most as of now to provide that technology support, because Industry 4.0 concept has to be fed into the mindset of the Indian steelmakers. So that is what we need to do consistently. With that, I would like to ask if there are any questions, or we will move on to the next presentation because Mr. Kandariwala has to leave. Ankit, any questions?
No, we don't have any questions in.
Yeah, someone asked for the presentation of Danelli, but let me tell you, Danelli has a policy of not sharing presentations generally. But if Mr. Adesi would like to share his presentation, it will be there with us. But as a policy,
we can share some part of the presentation. We can give you in the next days. Okay.
Yeah. So that is fine. In that case, anyone can get in touch with me. Please drop in a mail to my email ID, which is nirmalia@steelmetallurgy.com. So if you drop in a mail to me, I'll be happy to share the presentations of today. So with that, I'll move on to Mr. Ganadiwala. Mr. Saurabh Ganadiwala is the CBO of Jindal Steel and Power Limited. So he will talk about the capabilities of Industry 4.0 and the implementation at JSPL. Over to you, Mr. Ganadiwala.
Thank you, Mr. Nirmala, and good evening, everybody, and good afternoon, people who are in Europe, and good morning for the people who are in US. So it's a very unique combination that we have 3 time zones when I'm presenting. So thank you for giving me this time. And what I'm trying to do is I've just put together one small set of information, which you can call it as a digital framework for a steel industry. And I'm trying to explain with these slides of what actually digital means for a steel industry, and then take it specifically to Industry 4.0, and then just put together a few things which probably some of my fellow speakers have already spoken, but give you a perspective of what it means. Just give me a minute. I hope you can see my screen.
Yes, it is visible.
Great. So I'll get started. So I represent JSPL. This is what a digital industry typically look like, right? So you can actually divide this into 4 parts. One is the core ERP system, the core infrastructure and applications, where you have the entire network, applications, and other things. You have other applications, which is where you need to focus on mobility, ease of use, and access. And the 4th pillar, which everybody is talking about, is industrial automation. But we have to be very conscious that all of these 4 together only form a complete digital industry. None of them can work in isolation, right? So why digital? That's the first question which comes to all of us, right? And what is the landscape typically looks like, right? So digital is all about, as long as you can impact on any of these 3 things, where you can increase sales, reduce cost, or improve the visibility to the data, right? Can actually give you speed, flexibility, quality, efficiency. Any new business model means, I think Mr. Ravi mentioned about sales through e-commerce, right? Steel sales on an e-commerce platform. That's a new business model. Environmental efficiency, health, safety, security. If you fall a problem into any of these areas, that's when we can say that we are into digital manufacturing and we are trying to transform the business, right? What actually this all contains. So I go back to my core principles of core infra, enterprise IT, and industrial IT. Core infra is all about cybersecurity, network and DC, productivity tools, which is your basic tools for which you need to operate. And then the enterprise IT, which is where you do customer interactions, employee engagement, and the core ERP. And then comes industrial IT, which is where connected mills, IoT, and converting data to decisions, right? So this is the entire digital landscape, which actually comprises and say that what it means to take a digital journey. We'll probably go now deep dive into what is the relevance of digital for steel industry, right? So let's look at it like this. So these are the 4 blocks which I have on the right hand side. So it starts from the production efficiency, start from the upstream, right? Start from the upstream, wherein you start from the raw material to blast furnace to further downstream mills, and cover the entire 9 yards. Quality, flexibility, and productivity, as I said, are very important. Real-time operational data is one of the other key parameters which actually forces us to look at digital. Then contribution to safety and sustainability in order to reduce the industrial environmental impact. And finally, the downstream production areas like rolling and coating and finishing mills, interaction with customers they are finally the most benefited ones, where all it touches everything, right from raw material management, ordering, planning, sourcing, supply chain, logistics, distribution, sales. So digital is everywhere. what exactly, what is the methodology which you have to take to actually arrive to a solution or think that whether digital is applicable here or not, right? So first is study the problem and think innovative solution. One of the problems which typically happens is that we have a technology in place and we try to find where to put that technology. Don't do that. First is understand the problem, and then once we start thinking the solution, it can be a combination of multiple things, and as long as we can solve the problem, it is the right solution, right? Developing digital DNA. I think one of my fellow speakers in the initial stages, he talked about culture, people, right? How do you train them? How do you get acquainted them with the technology, what is available? Adopting new technologies for the digital DNA, right? We should have everything which is base your decisions on data and not feelings. We should not have that this looks to be working fine. The only thing which works is what is right and what is shown by the data. Last, co-create and co-innovate with new partners, as Mr. Dubey mentioned, right? A COE with industry connections, mentorship, and so many other things. That's the right model where you have so many people working on the ecosystem where we are trying to solve a larger problem for the industry, right? And everybody talked about industry 3.0, industry 4.0, when 3.0 was only about automation, right? 4.0 is talking about autonomously working without intervention of human, and Mr. Anderson showed that a pulpit without any people, right? So that's the future. Now, what are the digital technologies? So I have just put this in a very simple way just to make sure that everybody gets a feel of what all technologies we are talking about, because there's so many things, right? It starts right from sensors, and from here I am just focusing on industrial IT. I've left the other two pieces, the core IT and the enterprise IT, for this discussion, and I'm just focusing on the industrial IT. It starts from sensors, goes to computer vision, IoT, digital twins, AR, VR, mixed reality, RPA, analytics, mechatronics, drones. And trust me, everything has got application. Now the decision is which one to do first and why. Now, how do you do that decision? So this is something which I had put together for my own evaluation. So digitization house of evaluation, right? What do you typically do? You get a problem statement, you find an innovative solution. How do you do it? You basically look at what is the effort required, what is the payback. If the effort is low, payback is high, it's wave one. If the effort is low, payback is, even if it is low, I can still do it as wave two. The moment effort is high, but the payback is also high, I can probably do it as wave three. And if effort is also high, but payback is low, that's something which is the last priority, right? So this is a very simple method of evaluating your digital projects. Now, what can be your three key things when you are doing this? First is the implementation time. Take the strategy part of it. What can you implement quick? 0 to 3 months, 3 to 12 months, 12 months and above. What is the payback? Anything which gives us ROI less than 6 months fall here. Anything which is more than that falls in any of the other three buckets. Culture impact, acceptance, right? How do you invest in people? How do you train? How do you actually enable the industrial automation teams on the floor so that they get aware of the technology, they get to know that what this technology change can bring to them, right? And finally, I would say that digital transformation is the core of the industrial revolution. The last slide I have here is a typical example of what digital journey should look like and how can we get started, right? So, and everybody has been talking about data, and data is the new oil, as they say, right? So first is all parameters important to carry out the process. The fundamental is are always recorded. They are always available in our L1 systems. The problem is how do we get that, right? Once we get it, the first stage of any project, we should not try to boil the ocean. Do data collection. Once you have data, start monitoring, right? That's when you start defining the threshold, start alerting. And then once you have historical data with you, you get onto trend analysis, retrospective analytics, and predictive analytics, right? And in fact, if you translate it back and just extrapolate it onto a proper industrial platform, right? You start with data collection, consumption monitoring, go to production monitoring and work instructions. How can you use this data to give some work instructions? Get into asset tracking, where you start measuring OEE of each of the devices behind or industrial machines behind that. And then you take the journey towards maintenance, where you do time-based maintenance and condition-based monitoring, right? Remember, we talked about Industry 4.0 and all of this, but for any digital transformation to be successful, none of this work in isolation. You need to take care of your vertical integration, which is from sensors to ERP system. You need to take care of your horizontal integration, which is the entire production chain, and your life cycle integration, where you understand the entire life cycle of a plant from basic engineering to what it needs to do the decommissioning of that particular thing, right? Finally, I heard a lot about people saying that will AI replace humans? How important is it to have, what will AI bring to us? I know that some people might not agree. I strongly feel that digitization may accelerate and automate the process, but human experience is an aspect that cannot be substituted. So I would say value the human experience, and make sure that we do the things which are important and are very, very critical for the business. With that, I would stop my presentation, and I would like to hear any questions if anybody has.
Thank you, Mr. Ganeriwal. Thank you so much. You have also, I was honestly not aware that JSPL had already taken so many initiatives, because some of the other plants are yet to, take off. They're still at the takeoff stage. You have already taken off. So you're only yet to reach the cruising altitude, that's all. But you've already started with a good initiative at Angul. I don't know in Raigarh whether initiatives are in place in Raigarh. Now, Ankit, I have, before you take the questions, I have one of my favorite mentors who are there in the audience, Mr. P.K. Rath, CMD of RINL, whom I can see. Can you upgrade him to the panel so that I could get a comment from CMD of Vizag Steel Plant, who has taken so much initiative. In fact, he is the mentor of the entire COE. So can you upgrade Mr. P.K. Rath for once?
Yes, I've sent him the request to join the panel.
Okay. Ratsab, can you hear me? Ratsab? Mr. Rath, can you hear me? Okay, Ratsab's mic is still muted. Ratsab, can you unmute your mic, please? Ratsab, can you hear me, Ratsab? Can you, or he may be away from, anyway, we'll come back to him. Any questions in the meantime for Mr. Ganeriwala?
So we have one question which I think can be answered by any of the panelists. So someone wants to know what is the difference between level 4 and level 5 automation? Anyone in the panel would like to take that question?
I think Mr. Ravichandar would be able to answer. Mr. Ravichandar? Or Ravi can also answer. Ravichandar ji, once you answer, I'll put it to Ravi.
Hello. Are you getting? Yeah, I would not like to take this question now presently. Please get it answered by someone else.
Yeah, Ravi is the right person, because Ravi has seen the transformation from level 2, upgradation from level 3 to level 4. And Ravi, please go ahead.
Yeah, so Malida, basically the levels were all defined by some of the technology providers. Level 0 is generally the field automation. And when you get sensor assistance, you start getting level 1. Level 4 is basically the limit of automation at the full factory level. And when you start taking over autonomous operations, for example, autonomous cars would be a typical case of level 5 automation, where it is taking information from the environment and also reacting automatically.
Thank you, Ravi. Ramda, would you like to add to this?
I think the question was Industry 4.0, Industry 5.0 or something.
No, level 4 automation to level 5 automation.
There is no Industry 5.0 as yet.
Level 4 is basically up to the ERP level, that is the enterprise level, and level 5 goes one step above, have the business level. If you look at Tata Empire, they want to have a digital control over the entire business scenario of Tata Group. They'll go to level 5. And only Tata Steel plant, their automation level will be level 4, where through ERP they get the data and collection. If I understood the question correctly, this is a difference between level 4 and level 5.
Yeah, maybe I would like to support you on that, Mr. Ramachandra Chakravarti. So normally in ISA 95, it starts from level 0, that is the sensors, then the level 1, that is your PLCs, and then the level 2 is the models. And level 3 is for the planning for your shop floor. For example, when you talk about an MEA system, that is a level 3 solution. So which will do a shop floor planning, blue collar.
Yes.
When you talk about level 4, that is your ERP system. It can be your SAP or any other ERP systems, which is a business system, right? So that can have a planning from a 6 months or a 3 months down the minimum, 3 months to 1 year. That is your business system. Now in Industry 4.0, when we speak about level 5, as various speakers already mentioned here, how we are integrating all the values from level 0 to, I mean, from the sensors to the PLCs, to the DCS, to the MES and the ERP systems, collating all these informations and getting you more and more insights. So that can be, what I'll say, different aspects, right? So for example, if you have a logistics system, you need to improve your logistics optimization with respect to the quality and your vendor, what I'll say, vendor score or the defaulters. So that can be a part of this level 5 and all this analytics when the high level we speaks about. Even in the quality, somebody speaks about the complete genealogy, like a biometric, right? So where we are getting the problem exactly, what is your cost ownership for each area in each piece. So those analytics, those intelligence will come in level 5. So everybody is working for that. Even when we talk about an AI, okay, in my presentation, I'll cover probably, it needs to have a go various steps. So where we are standing right now and where we need to take it. So level 5, you just see a master system.
Right. Thank you, Pravinji. Manish, would you like to add anything to that?
Yeah, I would agree with Praveen's answer, but honestly, till level 3 and level 4, we have exactly defined what is level 3, level 4, and level 5 is, I would say the line is still blurred, and probably we have to have more discussion on exact definition of level 5. But in concept, I would agree with Praveen.
Yeah, exactly. Manish, up to level 4, it is defined. ISA 95 standard is fixed. Now we are in a journey, right? We are in a Industry 4.0 initial stage. So yeah.
Thank you so much, Manish and Praveen, both of you. Now, Ankit, would you play the SMS video before Manish starts his presentation?
Yes, yeah.
So we'll have the video presentation of SMS video.
So is my screen visible to everyone?
Yeah, absolutely.
Yeah.
Thank you, Ankit, for the presentation of SMS. I think we saw all the solutions which were highlighted here. We saw it on a much better scale in MITEC last year, Ankit, if you remember.
Yeah.
During MITEC SMS digitalization with Bernard, we saw most of these solutions at MITEC. So with that, let's move ahead with Manish with his presentation from SMS Digital Solutions for Industry 4.0. Manish, the floor is yours.
Thank you, Mr. Mukherjee. Thank you for the opportunity. Thank you everyone for your time. So I'll start right away. So the screen is visible, Ankit?
Yes, we can see. It is, just put it on, yeah, it's on full screen mode. Perfect.
Okay, thank you. So digitalization could be back office digitalization, but I will focus more on industrial digitalization. So the challenge in industry are known to metallurgy since decades, but now we have the technology available to solve them. So if you talk about a brownfield plant, be it, let's say, long route, be it flat route, hot strip mills, or be it like Steckle mills or something else. So you always start from asset health. Typically, people start from asset health, and the idea is to improve the OEE, overall equipment effectiveness. Once you do that, then you would like to focus on product quality so that you reach the target quality every time. Once you do that, then the next area you would like to take is the production planning. And this is where you really start getting a lot of benefits out of industrial digitalization. Once you optimize your planning, then you would like to go in energy to reduce the energy cost. Of course, if you want to do that, you need a basis. So you need the data, smart data, big data. So this is where the data factory comes in the picture. And this is, let's say, your source of truth for everything from the planning, energy, quality, and asset health. And of course, as it has been already mentioned by Mr. Ganeriwal, that you need learning algorithms, and these algorithms should be applicable on whole process value chain, right from the raw materials to the finished production. Our customer typically add 6 to 8% on the profit by going through this transformation. So let's look at the asset health. So when you talk about asset health, normally your goal is to reduce the maintenance cost and to reduce the downtime. So we have AI-based application for the asset health, which does exactly the same thing. Here you are targeting the health of the asset. So maybe the asset is broken or not broken. So this is one part of the equation. Another part is the process condition. Let's take example of looper in a hot strip mill. So one point could be that the looper is, let's say, broken or some sensor is not working. But it can also happen that everything is fine. I mean, it's not broken, but the response of the looper is not ideal. And this is where the process condition analyzer or the PCA comes into the picture. So let's say the response is not ideal. That means it will have effect on the quality in terms of shape, or in the worst case, you may also have loss of production. Let's say you have a cobble. So this process condition analyzer, this gives you real-time insight into process condition as well as the asset health condition. So here you could see what's happening in each plant section or where the problem lies. You also have 3D animation to help the operator to monitoring the process condition in live. Of course, this you do with the process rules, and you can have the overview of the process rule. You can find out which rule is violated or which equipment or which area is affected by it. And you also have expert advice for the operator. So this is more to help the operators, young operators or the fresh operators, and give him advice from your other best operators or the best practices. So if you combine both things, let's take the mini mill example. So you already have your existing automation, level 0, level 1, level 2. On top of this, you install condition monitoring system, the signal based. You also put intelligent sensors, intelligent component, and assistance system. So in the end, what you have is offline condition analysis. So basically here you are trying to do the condition analysis of your hydraulic valves or the cylinders, if the response is ideal or not. Then additionally, you are doing the online condition analysis of the equipment. What is happening with the thickness across the plant? What is happening with the vibration monitoring? What is happening with the work roll bending or the backup roll bending? And on top of this, you have intelligent assistance, because your aim, if you are operating a hot strip mill, in the operating aim is to know one question: if my rolling condition are stable or not, if my mill stand is rolling stably, what is happening to the mass flow, the calculated mass flow? Is it exactly matching with the actual situation? If there is some issue with one of the sensors or the measurement, or maybe someone would like to monitor the torque amplification factor for the health of the mill stand or the drivetrain. So this is what the intelligent rolling is. So of course, once you are through with the process condition, then you would like to focus on the quality. So the aim of a steel plant normally is to reduce the downgrading. So you are always producing the prime quality. The solution we have for this is QES, Quality Execution System. So this again takes the rules. You can have the pre-installed quality rules across the plant. So basically you are looking at right from the steel making to the end product. You have the rules for this. And here you see all the data which is relevant for the quality are used, and you can see them. You can also monitor the process parameters which are relevant for the quality. And of course, the most important part is the genealogy. So this software has the genealogy, that which coil is coming from which slab, which heat, and so on, and what happened to the journey. This was already mentioned by some panelists, that you would like to have this information attached to the coil. We already have, okay, this is few weeks back, the slide, we already have 41 references by now. One example would be a European steelmaker. Just with the quality solution, they are saving more than 20 million euro. This is kind of savings you can achieve from a quality system only. Of course, Mr. Singh already spoke about this idea. So we already have implemented this. So this idea is the predictive quality. So basically here you take the data from the heat, that is from the steel making, you take the chemical composition, you update the data with the caster, rolling mill, PLTCM, you take all the data and you keep trying to predict what would be the quality with the AI. And of course, here in the CGL, let's say this is your end product. So before the CGL, you would like to see where am I getting it? If I'm getting to my target quality, if I'm not getting to the target quality with this prediction model, then I have to optimize something in the CGL. So for example, if you take the example of tensile strength and you know with this model, prediction model, that you are not reaching the tensile strength, then of course you have to optimize the level 2 of CGL. So you reach the target quality. Another product we have is called intelligent furnace, same concept. Another example, so you take all the upstream data. Additionally, EMG has, for example, IMPOC system, which can measure the yield strength and tensile strength online. So now you get the online feedback of yield strength and tensile strength. You take all the data with automation data into a data factory, and then you have a data-driven model for the annealing line. And now this is generating the process parameters from mathematical modeling or AI. And this is telling the level 2 or the level 1 system what should be produced and how it should be produced. So you always reach the target quality. So this is the intelligent furnace. Of course, once you are through with, let's say, the condition and you are achieving the right quality, then of course, next area you would like to see is planning. So if you really see the steel plants today, it's mostly the sales is managing the production. Ideally, the production should be managing the sales. So basically, you should try to sell the coils or the products which are matching to your production schedule and where you are getting the maximum profit. So the collaboration between the sales and the operation is really the key. So our MES system, I mean, it's modular, so you can pick and choose the module based on your requirement. We already have artificial intelligence in some of the modules. And there are some interesting use cases. So this is a use case from American steelmaker. So the target was to reduce the minimum order quantity. Typically, I think in India, the minimum order quantity would be like the capacity of the 4 heats. Here, the customer is doing really interesting thing. If you see this one heat, they are producing 1, 2, 3, and 4 different orders in one heat. And the order quantity, if you see, this is the order of only 3 coils. This is the order of only 2 coils. So they are really optimizing the minimum order quantity. And at the same time, they are also reducing the transition slabs. So they are saving about, let's say, 4.3 million US dollars with this optimization. Of course, we have all the traditional modules in MES 4.0. What we recently have developed is AI-based demand forecasting and pre-grouping. This really helps the MES system or the production planning to go the next level. Of course, the last area where you would like to focus is energy. So here, basically, we have 3 levers. One is efficiency. So here in efficiency, you try to reduce the energy which is utilized to produce the steel. So for example, for 1 million ton production of the steel, you would like to optimize your energy or reduce the energy. Second area is if you are good planning system with AI, you can reduce the unit cost of that steel production or unit cost of that energy. So in one lever, you are reducing the energy, and with another lever, you are reducing the unit cost of that energy, and combined benefits are really fantastic. Of course, you also have overall energy management system, and you also reduce the carbon emission system, which could also be, I like this idea because this could also be a good sales strategy from a customer. So they declare this as a green steel, and they also mention it, how much of CO2 has been saved through this energy optimization. So of course, many of the panelists already spoke about the quick hits. So these are mainly the process specific solution. So you implement a use case, you solve that use case in one of the small solution, of course you get the benefit. But the real benefit lies in the interconnection. When your condition, quality, planning, and energy are interconnected, and if you have interrelation between them, then you really amplify the value addition. We also have the AI application based on top of this. You can also call it, let's say, level 5 or something. So I will show you a few examples of this. Since Mr. Dubey already mentioned this, if you have BOF converter, then slopping could be an issue. You lose production and operating time because of the slopping. So we detect the slopping with audio and visual data. This is quite an old concept, some years old. We already have more than 10 references. We have implemented it worldwide. Then you predict what is going to happen in the future with deep learning algorithm. So you take the data, you take the process signal, and you try to predict what is going to happen. And once you are able to predict, then you try to prevent it. So you influence your process or the process parameter in a way that you detect something very early, you predict it, and then you prevent it. So basically, then you can avoid the slopping, or you prevent the slopping. We had implemented it, and it is, let's say, it's saving more than 900 US dollars. $900,000 US. Another example, this was also a topic mentioned by the panelists, is the detection of the cracks. For example, take longitudinal crack. So conventional systems are good in detecting the cracks generated from the mold. But this AI-based application can detect the cracks also generating, for example, from the secondary cooling, or also from, let's say, the metallurgy or the chemical composition due to the steel making. So here, with this AI application, you can really predict the chances or the risk of having a crack. Of course, the next target area is 5G. So you can have a 5G network for your plant, and the use case is to reduce the cabling or to eliminate it. So basically, when we see the typical steel plant environment, it's very harsh. And if you, let's say, want to install some sensors near to the mill stand in a hot mill, it's really challenging, or near to the converter shell. So cabling is an issue. So current solutions are mainly based on the Bluetooth, but the Bluetooth has some issues. For example, the speed of the data and so on. So 5G is the answer for this. You get the high data rates, you also get low latency, and you can have high number of connected devices in parallel. We already did 2 pilot projects for this. One is for the safety in the transfer car, and second is the asset health with the vibration measurement. So these are the 2 areas. That's it from my side for today. Thank you very much for your time. You can reach me on these contact details. You can also scan this QR code, and you should get these things already. Thank you.
Thank you so much, Manish. Thanks for an excellent presentation. Well, any questions for Manish? Ankit, are there any questions for Manish?
Nirmalo, I would like to have one small question.
Yes, Subratala, please.
Just to Mr. Manish, an interesting topic he gave. Just as once, maybe a silly question for him. Is it the same 5G that has turned the world this way, that way, of way that you spoke about?
Yes, the technology is the same. The only difference is we are not talking about the 5G network for the mobile. So then a steel plant would install own 5G network, which is not, let's say, utilized for the mobile communication, but it is utilized for the plant. And of course, 5G is, of course, one company could be leader in this, but there are also other companies, and we are also working with other companies for this 5G.
Good. Thank you.
Mr. Bhatt, we have a couple of questions for you from the audience. So one is from Mr. Vikas Kumar Agarwal. Mr. Agarwal, can you hear us? Mr. Agarwal, if you could unmute yourself and ask your question. Okay, so we will come back to Mr. Vikas Kumar Agarwal. Our next question is from Mr. Patra again. Mr. Patra, if you could ask your question.
Thank you, Mr. Bhatt, for an excellent presentation. My question is that for your mechanical property prediction, say for hot roll coil, we know that the property depends on the final microstructure what we achieve, and that microstructure depends many factors, right, from the chemistry, then casting parameter, and then reheating parameter, and also during your reduction in the mill and in between cooling or so. How in detail you are capturing those impacts on the even the metallurgical factors in your design? I just wanted to have an...
Yes, that's a good question, Mr. Patra. So of course, MPM or material property model, as you rightly pointed out, it monitors heating furnace and the rolling mill. And of course, the mechanical properties can definitely be more influenced from the chemistry or from the casting. So here we have AI-based application, which is considering everything that has happened in steel making, everything that has happened in casting. So here you capture all the level 1 and level 2 data from steel making, casting, reheating furnace, rolling mill. Even actually people wouldn't stop at the end of the hot mill. People would go till the last product. So then people also would take care of, let's say, a cold rolling mill, processing line, and so on. And then people would like to predict these mechanical properties. So if you are only looking for, let's say, mechanical properties of the hot coil, then MPM is the right part. But as you know, in steel making or in the casting can also have good influence to the mechanical properties. Then this mechanical property variability is the right application for this. So of course you have to have all the level 1 data, all the measurement. Basically you have to track the whole genealogy. What has happened to that strip before this?
I mean, it's not only the statistics, but also the metallurgical CCT curves, etc. All those factors to be, I think, inbuilt in your program to rightly predict the end final microstructure and then the properties.
Yes.
Okay, I think
for example, yes. So for example, as you rightly pointed out, yeah, these information has to be there. So it's also there in MPM. It has to be also in AI driven app. So then you are already knowing the physics. So the physics part, which is known, we need not to learn from AI.
Okay, thank you.
We have another question from Mr. Ashish Pandey. Mr. Pandey, could you ask your question?
Hello. Hello, sir. Good evening.
Go
Yeah,
ahead, Mr. Pandey. Go ahead.
Yeah, sir, Mr. I have a question regarding Mr. Manish. Sir, 5G. You have told me the 5G. Where have you used the 5G? I'm working in the SMS department, JSP Langul, and I am fast experience in rolling mill also. Where have you used the 5G? You have to take. I'm working in electrical automation. Yeah. Cable costing
so 5G. Yeah, so there are basically two, let's say, pilot projects we have done on 5G. So one, of course, is the, let's say, condition monitoring system. So let's say in rolling mill, if you want to, let's say, measure torque amplification factor. So basically you have to measure maybe the torque, or maybe you want to measure the vibration. So you know that, I mean, the physical system with the cable connection, it would be difficult, and that is quite a challenging area. So with 5G, you can have a wireless communication between the sensors and RIO.
Yeah.
Of course, the Bluetooth technology is there, but you know, with the Bluetooth technology, you are limited in terms of resolution. And here you are not interested in average signals or RMS signal. If you really want to measure, let's say, torque amplification factor, then you need maybe resolution in tunes of, let's say, 2 millisecond or 1 millisecond. What kind of resolution we get with the EBA. So then we need a system which can give, let's say, higher resolution. And that is where the 5G comes in the picture.
Oh, sir, query regarding, sir, some, maybe, sir, if a Wi-Fi system, maybe some PLC interruption will be there. Sir, if any 1 millisecond cobble flickering time will be millisecond, cobble has been detected. Or if any interference in the PLC system, how to, sir, overcome from Wi-Fi switches?
I see. These are the data you are getting in terms of, let's say, milliseconds. But for sure, you are not going to make this decision again in milliseconds. So, I mean, how would PLC would
because a PLC is a Profibus communication from RA PLC to RA communication. But in Wi-Fi, how to data interrupt? Maybe data has been signal losses. Maybe plant has been interrupt. Production has been lost in the Wi-Fi system.
Yeah, maybe if I can address Mr. Pandey's question. My name is Kalyan. Pandeyji, what you are saying is in terms of how the Wi-Fi interaction happens. See, from the PLC system, what happens through the Profibus interaction, you are actually taking the data from either a Profibus by converting it to some sort of a Profinet technology. So Profibus to Profinet, there will be a protocol conversion, and then that protocol conversion is captured onto some sort of another edge controller. It is not that the PLC would directly dump data into an external world, primarily because the transfer rates of PLC is going to be very slow because of the nature of technology, right? Whereas you want to do a processing and a post-processing and transfer the collated data. For that, you're going to have another edge controller which has sufficient CPU, RAM, and computational capability, and that is the one which is going to be connected to Wi-Fi per se. We wouldn't want to directly take PLC because PLC has a RT activity, right? Real-time activity. So its loop is the most important thing. Communicating the data is not the priority for the PLC. PLC is least bothered whether the data is going out or not because it has to do the real-time activity. That is its top priority. So communication is not its top priority. So for that reason, normally what is done is we normally create a push technology where we have an edge controller which will take care of the communicated data, consolidate the data, and pump it on either any sort of technology, Wi-Fi, or definitely not Bluetooth, like what Manish has clearly mentioned. Bluetooth is not the technology for, at least definitely not the technology for the steel kind of industries, though I know many of them are using it, but that's not the most preferred technology. But Wi-Fi certainly is, and 5G would certainly be. So, the combination of Wi-Fi and 5G would definitely go a long way, if I have addressed your question, sir.
Okay, sir. Okay. Thank you so much.
Thank you. Thank you so much, Kalyanji. And thank you, Manish. Well, since we are running beyond schedule, so we'll have to hush up a little bit. And may I now request Mr. Ashok Nath Biswal, DGM, IT and ERP of RINL, followed by Mr. Minesh Mohile, AVP, Information Technology, JSW. Both of them back to back. Please go ahead. First, Mr. Biswal, followed by Mr. Mohile. The floor is yours, Mr. Biswal. And Mr. Mohile, you can begin just after. Yes, you are audible.
Sir, am I audible to all? I am
absolutely audible.
Online.
Absolutely audible. Please go ahead.
Audible now, sir.
Yeah.
So, thank you, sir, for giving this opportunity to speak a few more things on my IoT. We have, in fact, I will talk of two things. One is the process which we have adopted in Visakhapatnam steel plant. That is, the problems are first derived from the site people. Okay, so we go and discuss with the site people, find out some issues which probably they may face, and then we come back to our workbench and try to develop a solution. Okay, so we try to develop a solution. That way, what happens is our things becomes easy. The involvement of site people is achieved. It's not that we bring out some hi-fi product and we push on to their neck to implement it. That does not work, I think so. So since the next meeting is on SMS area, I would like to bring out 10 problems which are process improvement areas which you have identified. And I think if somebody can work on this, it could be great, because this we have collected it from the user departments, SMS department, we have collected from them. For your benefit, I will read it out, those 10 problems. In fact, we have around 30 problems in all derived from different shops. But since the next meeting probably will be on SMS area, so I am just reading them out, and I want the house's attention on these problems. It could be an opportunity for some, and it could be it will be easing our operation, and we need to do it in a very, very cost-effective way. So first thing which we have identified is gas leakage inspection using drones. Okay, so I'll give you the brief. Our converter gas holder can be inspected by using drones for leakage of carbon monoxide gas. It is told that today the technology gives us sensors that can detect the carbon monoxide gas. So if we have a drone which can be operated, and we can find out if there are any leakages attached, leakages to the converter gas holder, which contains the carbon monoxide gas. This is one problem. I think people should note down those who are into this business. Then second thing, what we have thought, means it has come as a problem. We do not know whether it is possible or not possible, but because we have gone to the site and they have told us, sir, if we do this, probably it will be better. Then they were telling the cleaning of the converter lamps using robotic arms. You know, we have a basic oxygen furnace. We have 6-7 numbers of them. And once the lamps goes inside, it removes the carbon part. That is how the iron becomes a steel. And we put some alloying elements also. We call it ferrochrome, ferromanganese. These alloying elements, we add them to give the property to the steel. So we are, they were suggesting that this converter arm goes and it gets cleaned after 5-6 operations manually presently. Probably if we can develop a robot which can do it more efficiently than what we do manually, it could be great. Then the third problem which they were telling us is the steel temperature in Tundis monitoring to avoid choking and machine closure, etc. This pertains to your continuous casting area. Probably we can have a monitoring device, because the temperature is one of the important factors for casting. Basically, your important factors. Probably if we can have a device in place which will allow us to take corrective or preventive action. The fourth one, you may please note down, probably somebody is doing it, usage of thermal imaging to check the lining condition. Okay, the steel ladle lining conditions and data transmission to the level 1 for predicting ladle failures and avoid the ladle throughs. These scanners may be installed in LP bay. They have suggested we have a LP bay in SMS area. They have suggested this may be installed there. Okay, then we have a fifth idea which has come up, substituting casters in CCD by robots for continuous casting operation. This might look little silly, but this is one of the ideas is given. He tells what is the job of a caster. The caster usually monitors the casting process. Can we not put a robot and allow a human being to monitor the robot to do the casting process? Because the casting process is the skill where you make your quality of the steel depends in the casting also. Your losses will be less. Probably if you can put a robot there and do something on it. Then this is the continuous casting operation. These are wild ideas you may call sometimes, but probably we can work on them if we find it economically feasible. Then SMS CCM data analysis using big data and predicting the issues which arise during casting. Usually what happens is somebody presentation we are telling we have lot of data, lot of them. We have data available in the level 1, level 2 and all areas. And probably we can take some of the data and then predict in advance. If these are the conditions, then probably what type of steel I am going to make. So I'll give you the brief. This involves only historical data analysis using software analytical tools to predict most probable cases of issues and giving advance information to the executives to take preventive and corrective action. People say, I read somewhere also, history repeats. Okay, we had done a mistake yesterday, so we are facing the problems for that. So probably if we learn from the history and the data, probably we can take, and if we have time, we can take enough preventive or corrective action to make a better quality steel. Then some more suggestion has come on RFID based scrap box tracking, including automatic weight scrap fed to the converters. So RFIDs can play a big role in industries today, because you see this industry 4.0 has just not like that has come. Lot of converging technologies have come which has led to this evolution. You see, there is RFID which has come, there is IoT which has come, there is robotics which has developed, there are drones that has come. Okay, and there are many other things. Then analytics sides, you have got edge computing that has come. Python as a language has developed. So many things coming together is giving us an opportunity to make the machines more intelligent. Basically, Industry 4.0, what I understand is making your existing machines more intelligent. Okay. So RFIDs can be used for, say, automating your scrap fed to the converter. Sometimes scrap has to be fed to maintain the temperature. Okay. Then we have ladle or vehicle tracking using image processing and photo area switches inside the subfloor. Sometimes the ladles have to cross the subfloor where there may be manual movement of people. People may move from here and there. Some sort of sensors, photo-based sensors, if it is there, and if it is able to detect somebody moving in that track on that point of time, probably it will stop and avoid an accident, because people work 24 hours, so day in, day out. So it can avoid, it can be better if we have a solution, small solution, cost-effective solution. Probably we can do that. Then vibration and load sensors for critical equipments like lens drives of converters and BOF steel drives. You understand, they are huge equipment, huge mechanical equipment. Somebody has to see them to believe. I believe I remember some senior lady visited our plant and we took her to SMS. And after seeing the SMS area, she was telling, probably God has made this up, because equipments are so huge. It's really, so if we need to monitor them with the help of sensors, we can take advanced preventive or corrective actions. Okay. Then the 10th point is Industry 4.0 based solutions to detect pouring of hot metal outside the container, outside the converter, and still outside the emergency. That means we want the metal should be poured wherever it is. In fact, after this, our team who we were working on, we will be going to not other departments, discussing with our basically users, subfloor, shift managers, and see if something we can do in a cost-effective manner, so that quality improves, the quality of the steel produced at the end of the day improves, and we have a better customer satisfaction in terms of quality of steel, because they are the people who drive our business. So our most important aim should be to have a better quality steel. So that's all, sir. And I am closing my session. The chair may take up for question and answers, if any.
So, any questions for Mr. Biswal? Any questions? Okay. Now, before we move on to Mr. Mohile, I hope you will not mind if I put Ravichandra ji for once. He's your senior colleague in the company.
Sure. Definitely.
So let Mr. Ravichandra ji complete, and
Sure,
then you
sir.
can continue.
Yes, definitely.
Thank you very much. Very good evening to all of you. A lot of learning today. I was only initially thinking that I'll be joining late because there was some other conference was planned. Luckily, it got cancelled. I am able to attend from the beginning. I think I always would prefer my younger colleagues from various JSW units to address things in detail. But as such, I have not made any preparations because it was a last-minute inclusion. So I would like to say some of the things which I was able to participate to a greater extent when I was in Salem some years before, 3-4 years before we started these drives. And in Monad, it is steel making has just started, and we are in the initial stage of discussions on digitizations. As such, when we started these discussions times before, there was always a confusion: what is digitization, what is a digitalization, and what is the digital transformations, and all these things. Then afterwards, somebody has explained with a small pyramid drawing. Okay, digitalization is the base of the pyramid, and the digitalization is a base, so superstructure little above, and that the journey is towards the digital transformation, which is we can go to the peak of it. And even here also, I think some places the digitization word is used, and the digitalization word is used in some other places. What I was able to enjoy this journey in the initial age after the threatening presentations by the digital experts, because the first time organization introduced, they threatened us with some words, cyber physics, Internet of Things, big data and analytics. horizontal vertical integration, autonomous robots, cloud computing. When we heard these things around 4 years before, we thought we are just Greek and Latin, it looked for us. But when we started discussing with the operating team and implementing things, when our with what of problems we had, then we started enjoying the journey in bits and pieces of implementation. Maybe today Salem unit has crossed more than 20 plus initiatives. I'm just trying to recall some of the initiatives which when I was there 3-4 years before we started. As a special steel alloy plant, special alloy steel plant, we used to have some cost pressure always is there with anybody. And this ferro alloys used to be the biggest cost. It's costing around 3,000 to 4,000 rupees per ton in some sizes, and maybe sometimes more than 5,000 rupees per ton. So if any small reduction can bring in a big saving. So that are the first project in Salem which we have taken up, and how to optimize ferro alloys through digitalizations and making a modeling and then trying the models and enhancing to various alloys and other things. Towards this process, practically, we were able to achieve 2 to 3% of ferro alloy saving when you talk about 4,000 to 5,000 rupees and per ton alloying cost, and a 2% saving gives you 4 to 5 crores in a year. So that's a big saving, even though per ton it may look like 80 rupees to 120 rupees per ton. For a million ton plant, you have to multiply everything by a million. So that becomes a bigger saving. Basically, I think we would like to start like this, because in this, we have already seen there are 3 type of people, if I understand. Digital stalwarts are there, and the words they use many times is not able to be even understood by many others. And the industrial stalwarts who have mastered the digital applications are there. There are that category of people who are in the initial stages who would like to know what is this and then how it can benefit this. Possibly, I was thinking that the high-end talks are over. I would start the low end so that people can understand something who are at the first time or an early runner for this. They should be able to understand. There's another project what I've taken, because we found that the blast furnace gas, there are multiple blast furnace and much more multiple users in the steel plant, where we find that even you save a 2% gas from flaring, you will save 3 to 4 crores of rupees in a million ton plant. So we started working on that. Okay, these are the supply side variations of the blast furnace, and these are the utilization side variations of the blast furnace gas, and applying it with the digitalization technology. And we were able to achieve the target of 2 to 3% very easily, and in the minimum possible time. These are the small bits and pieces with not a huge investment, but one by one, everything saves something. And at the end of the day, if you see accumulation of all these initiatives, really saves a lot for the organization. And our flagship company, Vijayanagar, I think someone is going to be presenting their achievement. It has done over 60 digital initiatives with enormous savings, because that being a 12 million ton plant, any savings per ton, you have multiplied by 12 million, naturally it becomes a huge number. Basically, these are the things what I can find. But with Salem is currently doing some lot of initiatives. With some of the things include the latest issues like crowd detection, social distancing models, which can be configured on a need basis. Talking of inside the plant, there is too much of a vehicle movements are there, and vehicles, plant vehicle movement information alerts and information system. These are all something which has been very much good for the safety point of view for the company. Basically, they were all working on automated adjustment of coal injections, coke rate, hot blast temperatures, etc., using the LOT platforms. And in the sinter plant, started working on the sinter return fines reductions. And then looking at the SMS, a lot of other initiatives were there in the SMS. The LRS process time reductions as such, the dynamic steel prediction models, then the hot metal silicon percentage of variability optimizations models, and in either EOF in Salem and BOF elsewhere, the cycle time reduction through automated blowings, the oxygen consumption control in blowing. These are some of the things which have been taken up, and then they are doing very well in it. And then everything is really assuring a lot of savings. One particular model of interest will be, say, like an alloy steel plant like Salem. You have 2 steel making furnaces, and then 4 ladle refinings and 2 VDs, followed by 3 casters, and every caster has its own limitations in handling various sizes. And you have more than 1000 product standards and 150 alloy variants. So under these conditions, how to optimize this? This is one of the challenges, I think, which we will be already taking up in the near future. How to optimize this so that you have to achieve a production of even more than 1 million ton, because so that can be achieved only through such a processes. So these are the few of the things which I thought I can add to. Possibly we are talking in the Monet, including the other preliminary processing units, like we have a 2.2 million ton pellet plant. We are looking at the possibilities of pellet size optimization, because these oversize and undersize rejections are coming to be very high. As it is, Monat is not at the levels of Salem or any other unit, so we are in the preliminary stage. That's why I thought talking about what has been done in Salem will be of a better information, more useful information than others. So otherwise, what is happening is that whenever we see people's presentations, many of them finding it difficult to understand. It's just like if you have seen a definition of mission in the Hindi movie 3 Idiots. that definition, it goes something like that. And basically over a decade, even the word technology has been hijacked from the hardcore industry by the IT industry. Okay, with all, I thought these few words I would like to end, because it was a last minute entry, and then I could not make any preparations for this. Thank you very much.
Thank you, Ravichandra ji. You don't need a preparation. You are a man born and bred in steel, and you have seen the entire transformation in the industry. For those of you who are not aware of Dr. Ravichandra ji, Ravichandra ji is the whole-time director, and he is running the Monet JSW plant right now, and he has spent his entire life I would say with JSW for a very, very long time. And he's running Monet JSW right now. He's heading the plant, and also a whole-time director of Monet JSW. So with that, I'll move on to Mr. Mohile, because we are running 1 hour late almost. So let us move to Mr. Mohile. After that, I think we have Mr. After Mr. Mohile, we have Mr. Ramchandra Chakraborty, Ramda, followed by Mr. Rohit Gupta. So Rohit ji is getting a little impatient because we are running so late. Plus, please bear with us. We believe in what we call Indian stretchable time. So please get adjusted to it. So, and interaction is very important in such webinars where we come out with ideas and share thoughts. So with that, I'll hand over to Mr. Mohile.
Right, no worries.
Thank you.
Thank you, Mr. Mukherjee. And it is very nice to speak after Ravichandra Saab. My greetings to all seniors, attendees, and the panelists. I also could not make up a presentation because I got into just yesterday, but quickly I will take you through, in addition to what Ravichandra Saab has said. So the first and foremost thing that generally we try to conceptualize on a project is to create a team and start the project and complete it. That's not the way the digital arena goes. The first and foremost thing that we are doing at JSW Steel is to ensure that the foundation is strong. The pieces which are needing upgrade are upgraded. What needs to be put in place in terms of things like historian to collect the time series data. There are several plants which are old also. So we need to put, those plants did not come up with these kind of facilities. So the first step is to ensure that the foundation is right. There are upgrades of various equipment. The second important thing which runs in parallel, which is the first and foremost thing that I spoke earlier also, is the culture building. Today, starting from top to bottom, as you can see, Ravichandra have giving you so many examples of what we have done in terms of digitalization at Salem. Elsewhere in all the factories, in all the offices of JSW, you will see it's not at all a buzzword now. It is a matter of culture. That is something which we are trying to run across the organization. The next thing comes up is on the ideation or the innovation, and then to co-create and co-innovate. So I will try and give you an impression on the 4 or 5 important areas where we have tried the attempt on digitization or digitalization. The first area is about the foundation building. So wherever we don't have the manufacturing execution systems, wherever we don't have historians, we are trying and putting all those things in place. Number 2 is the optimization. So you heard him, Mr. Ravichandra, say about the ferroalloy optimization. So this is exactly what we have done at Vijayanagar also and Salem also. It uses a brute force algorithm, and that is how we have optimized the cost to a very great extent. The benefits are enormous, and we are trying to replicate this particular scenario to other plants of JSW as well. Second important thing that we did was the blast furnace charge mix optimization. This also has given enormous cost benefit, and it has improved the manner in which we do blast furnace charge mix. The first thing it eliminated was the operator fatigue and the kind of manual interventions in terms of data. So that is something which also gave us a huge cost benefit. The second track that we are pursuing is on the prediction technology. So the first one to pick up was the phosphorus prediction. So as you are, everyone on the steel industry is aware, it is the tapping decision that is very critical in terms of the converters that we operate. So we tried and analyzed phosphorus prediction. Of course, we tried multiple methods. We were trying multilinear regression. We tried the random forest, and we tried the SVM, the support vector machine. We found that the random forest was giving us the best opportunity and the best results. And we went ahead and did phosphorus prediction. The second one we did in terms of prediction was a huge mammoth system on the quality prediction. So this is something which is currently also in process, and we are yet to achieve the complete project out of this, but we definitely have done a huge project on the process quality management that we call it the quality management system, where we get alert in terms of predicting quality, so that we can, as we all know, steel can be sold at multiple stages in the routing as we go forward, from pickling to cold rolling to galvanizing and so on. So this technology gives us an edge over in saying that if there is a problem here in this particular process, do not add further cost and process it to the next. Sell it from where it is, we pick it up, get the quality prediction, and we prevent that particular damage in the next process. The third kind of prediction is the maintenance prediction. That is something which we are trying to do now. We are putting up a system where we collect the sensor data from various machines. This is in a pilot stage, but definitely we are sure that we will do two things. One is to reduce the over planning or the planned maintenance, and also to reduce the breakdowns. We will get specific alerts so that we reduce the breakdowns of critical machines. The third area was the track and trace and the yard management. So this is where we have used RFIDs and GPS. And one important thing that we did was to have a GPS tracking on the torpedoes. So there was a temperature drop because the travel time was causing this. And when we tried using the GPS tracking, we could actually save on time. And also there was a lot of visibility that brought into the smoother operations at the steel melt shop. That was the third area. The fourth area was the drones. So we tried this particular technology at the mines area, and the survey was conducted using drones and was integrated with a lot of other sites. While we do all this, there is one fundamental aspect on the data collection, collation, and correlation. So this is what we have tried doing using a data lake, and we are implementing an organization or an enterprise-wide data lake, which can give us more capability on the statistical process control, the statistical quality control, and all the advanced features that we want to try and move into an area where we get the analytics done in all the functions of the company. So on an average, each location currently is having minimum 25 to 30 digitalization or digitization projects, and that is how we are trying to move into a digital culture at JSW. So thank you very much. I would try and answer any questions that would come up actually. Thank you.
Thank you, Mr. Mohileji. Thank you really for extensively covering what all JSW has done so far. Any questions for Mr. Mohile? Ankit, can you check if there are any questions?
No, we don't. We, however, have a question for Mr. Ravichandar, and it's from Dr. Arko Majumdar. So I'll just
upgrade Dr. Upgrade Dr.
Yeah. Dr. Arko Majumdar, can you ask your question?
Yes. Good evening, sir. In your lecture, I am asking Dr. D. Ravichandra, sir. In your lecture, you have spoken about achieving reduction in center returns with technology. Could you elaborate on this? Means how you could reduce the center returns percentage and what exactly you have done to reduce that? And another question is for Mohile, is that he was talking about the burden charge mix reduction. Can you just explain on that, some more on it? Because it is not clear what exactly you have done there.
Yeah. So, sir, shall I take my question first? Hello. Yeah. So, Dr. Saab, what we have used is iLog, which is the IBM optimization engine. What we have, the problem that we have is it's not a problem. It's a normal situation for any steel plant. We get raw material sources from multiple sources, and the composition definitely is very different. Okay. So that is what we have done. First, we tried and collected all the data that we had in the plant. And then we also ensured that the analysis that is done at the lab is flowing dynamically into the model. So I can give you more insights on the model if you are interested on how the iLog modeling has been done. But we used iLog actually. That is the short answer.
In fact, I was working in Vizag Steel and doing the burden calculations. We have a model for Vizag. But point is that how could you, because I was working there for 23 years. So my point will be in that how could you get the cost reduction and the burden calculation in a means it's a better way. How could you get? How could you manage the things? That's what is.
Yes. It's a very interesting thing, and we, for your information, we did it about 2 years ago. And when we first did it, it was a learning phase. So in the first 4 to 5 months, we were actually trying to develop model, and it was an iterative process. About 3 to 4 models we had to create, and only after the 4th model was up and running, we started seeing the results actually. Okay. So I can give you more details on what were the inputs in the software.
We'll speak out.
Yes, and how was the model being done? So that's
thank you.
Very interesting OR model, which is very nice mathematical scenario.
Thank you. Thank you,
sir. Ravichandra ji,
I just unmuted. Okay, and see, basically the approach is on the analysis of various data, input data, because it's a raw material input and the fluxus input, which has been mostly raw material input has been varying because The Salem has been getting different materials from different places. Sometimes most of the things from Orissa and some materials from this local nearby Karnataka and all. So the database was built up on the various inputs of raw materials and the fluxes, and based on the inputs, models were developed, and then based on that, further applications were made with the small models, and then extended to full scale. That was the thing. It was mainly input materials management and variations and all.
My question is, sir, actually, could you do something on the machines? Because the calculation and database will give you an idea how is the machine is running. So the process, if it is bad or if it is not properly maintained, you will not be able to achieve these inter returns. The percentage of returns will come not, it will never come down. But what exactly the input, you have controlled the limestone or dolomite or the fluxes. But if you don't change the process, then it will be, I think it will not give you any result. Can you just explain or elaborate on this, that what exactly you did with the machine process? Because I'm more interested of the process, because the process, if it is not giving good result, it will never reduce the returns.
Yeah, you are right. Process parameters do play a role, but what I was trying to tell you is that in this particular aspect, the material inputs have played a major role. Then process parameters, that not much of a variation was there. To get into the details, because we at the managerial level, we don't go into that much of details. Our technologists who have implemented should be able to provide more details on this. Okay.
Thank you, Mr. Ravichandran. Thank you, Professor Majumdar. Thank you so much. So with that, we'll move ahead with Ramda, Mr. Ram Chakraborty, who's a good friend of mine, again for very long time, since his days in Primetals. So I would request Ramda to take over. Mr. Ram Chakraborty is the Managing Director of PSI Metals India.
Thank you, Nirmallo. I just share my screen.
Yes, please. Please, Dada.
You can see my screen?
No, it is not visible yet.
Is it?
No.
No.
You have to select the share screen option first.
Yeah, I have selected that.
So if you have your presentation open already, you
Yes.
can then click on the share screen option and it will show you the presentation, the PPT window. And then you can click on that and click on share.
Yes, now it's okay. Okay. Yeah. Yeah.
Good evening to everybody. I think you are tired enough of listening to so many lectures. So, digital transformation, the journey, is a very important one at this point of time. And basically, I start with the questions of what is Industry 4.0? We have so many definitions, so many people are explaining it in so many ways. Let us see what is this. Basically, I want to say what it is not. It is not a technology. It is not a product, and it is not a service. Then what is the digital transformation in Industry 4.0 in a nutshell, in one sentence, is identification and usage of any kind of networking possibilities within and between factories and towards customers and suppliers. Industry 4.0 is much more a philosophy, an attitude, perhaps a framework for action. Why Industry 4.0? People may think. We say drastically seen, the question will not be why Industry 4.0, but when Industry 4.0. The term Industry 4.0 was coined in 2011, 9 years ago in Germany. And if you do not act now, it may be the direct competitor, one that you not even associate with steel industry, they will act. Why to change? Basically, Industry 4.0 is a paradigm shift in the way we source, produce, market, sell, and provide support and services. Collaboration in supply chain, horizontal digitalization, for superior demand visibility, standardization of data exchange and compatibility, and last but not the least, information security. Rapid market changes require faster adaptation, like price competition, pressure to innovate, higher requirements regarding quality, reporting, delivery times, and lot sizes. Realize new business opportunities based on context-driven data for process transparency, quality on demand, service rate fulfillment, reduced inventory, improved decision making. Typical reaction to unplanned events when it occurs and how we take a decision and what is the effect on the organization. If you look at, basically we take a lot of time. The inside latency contributes to the delay and analysis. Then we analyze the decision, what happened, why happened, something like that. Then we take the decision and then do the action. So reducing these latencies provides great potential to reduce value losses. So what we can do with this, the real value behind digitalization is this latency is drastically reduced. So when an event takes place, an organization can take a very quick decision. How can they do that? By the real-time capability system integration. Big data analytics, machine learning and artificial intelligence, when they are used to understand the reason behind an action taken automatically. And decision support systems, automated decision making, vertical and horizontal process and systems integration, and cyber physical systems. Of course, these are the technological drivers for industry. Steel industry to become a startup scene again, it is not enough to analyze case studies such as Uber or Airbnb, which is very big success in digital and era, because the abstraction of taxis and hotels towards the steel industry is not that simple. Copy and paste is not an option. So what we propose, PSI Metal Service Platform, the future-proof foundation, which takes care of adaptive best practices worldwide, agile implementation and non-disruptive upgrades, data analytics and predictive control, real-time responsiveness and optimization. Sorry, it moves a bit faster. Quality and reliability and multi-solution and IT operations. So these are the areas where we can help with our solutions. I don't want to elaborate details on this. Basically, the first accessibility of mobile devices in PSI Metals, we have a web-based solution. We have small screen like iPad or mobile phone, something like that. Touch screens, barcode scanner, camera integration. Then we support the business processes through material information, bundling of the information, transport management, stock keyword management, your PDA, personal assistant data acquisition, KPI visualization, and new ways of input and controlling the information using Google Glass or HoloLens like digital and data glasses, voice control, or Alexa, Amazon chatbots, and all these things. So basically, this is a very big presentation from my side. And people are talking about Industry 5.0 already, and they're using collaborative robots to assist human beings and utilize human intelligence and experience to do work together with the robots, and we are coming to a better result. And not only that, people are thinking of Industry 6.0 as well, where only apps will control a steel plant altogether. Thank you very much. Have a nice evening.
Thank you, Ramda, for being very, I would say, very short presentation, but very precise, targeting exactly what needs to be done. And the coinage of Industry 5.0 and 6.0 was really unknown to me till you spoke up to me today. As you know, my son is doing his master's in data science. So because he's doing data and knowledge engineering, I keep asking him what is new in this industry which is coming up. Ankit, would you like to comment on Industry 5.0 and 6.0? Have you touched that yet in your university?
No, but I have been studying about Industry 4.0, and I think Industry 5.0. What he mentioned, it can be it can also be considered as the fifth level of Industry 4.0.
Okay, it depends on how we look at it.
Yes,
People are using now collaborative robots to help. Now people are sometimes afraid that during such a high level of automation, people will be, I mean, sidetracked or something like that. But here, human beings are coming once again. The intelligence and will be used along with the collaborative robots who will be doing the monotonous work or difficult work for human beings, something like that. And Industry 6.0 is, I think, researchers are thinking that there will be so many apps now. You have apps for flights, you have apps for trains, you have apps for everything. So someday you have apps only to run a steel plant, and your steel melt shop or your caster or hot strip mill or your cold rolling mill or galvanizing plant or color coating plant, everything from raw material procurement to the finished products and shipping, everything will be in apps only. So I mean, I don't know. This is just some sort of, I mean, a futuristic idea.
Right.
Yeah, Manish, would you request Manish to share SMS thoughts on 5.0 and 6.0? Manish. Manish, please unmute yourself.
Sorry. So honestly, yeah, that's a topic of classification. I mean, we would like to focus more on the benefits and what we can do. One additional remark, whatever algorithms we have in artificial intelligence, they are really good in so many things, but they are not so good in strategic decision making. So if you have a planning system with full-blown AI, it will work fantastically, but when it has to make a strategy decision, for example, let's say if this order is more important for the company than the other order, for example, which will generate more profit. So who to decide this, and how to decide with, let's say, artificial intelligence? So strategy decision making, I would say AI is still, yeah, we have to do a lot of things in AI, and algorithms are really not so good in strategy or strategical decision making. So we'll definitely need humans before we find out those algorithms.
Ankit, your comment?
Yeah, so what Mr. Bhatt mentioned, this is kind of the research is going on in, if I would give the example of autonomous driving. So right now we have level 3 autonomous driving, and level 4 is under process. So when you look at level 5, it's basically when the machine is as good as a human driver. But when it comes to making certain decisions, like for example, you have an old lady in front of you, and if you are trying to save her, you hit a tree and hurt yourself. So would a human driver choose to hit the old lady or the tree? We'll probably go for the tree. We'll be like, okay, let's save the person in front of us. But will the AI take a similar decision in such a scenario? So this is something we have to consider, and it is a risk when the AI is faced with such kind of situations.
Very right. Ramda, you wanted to say something. Yeah.
I just forgot what I wanted to. I think I was reacting to Manish, and basically, AI is basically deterministic, rule based. All these algorithms are rule based. Basically, when you come into a human factor, emotion or something like that, Ankit has rightly said, AI has no emotion. Basically, you can't program emotion into AI. You can give rules, guidelines. You can number of 100 steps of rules. If this is, but they cannot go beyond rules. So when human emotion comes, saving the old lady or hitting on a tree, then really human intelligence or human decision making comes into picture, and that will be very important.
Thank you, Ramda. Thank you, Ankit. Thank you, Manish. So with that, we'll move on. We'll move on to our next speaker, Mr. Rohit Gupta. He is head sales, transport, logistics, metals and mining at L&T NXT. So over to you, Mr. Gupta. You've been waiting for a long time.
Thank you, Nirmala, and it was very, very interesting to listen to all the philosophies and what we have done so far in the digitalization arena. What I would like to do is give you a little perspective on what L&T has done so far. And digitalization in L&T was something which we took very, very seriously about 4 to 5 years ago, and it was basically a twofold kind of a strategy which we had. One was basically to help our own internal processes, and which will make sure that whatever we do it much better. The other thing which was in our mind was that can we take these solutions outside of L&T and help our customers drive their digital journey. So these are the two aspects which were there, and we kind of segregated a group of people who were helping us within the industry framework, and now we have a separate company, which is now focusing on digitalization and Industry 4.0. And this company's name is L&T Next, and we have a lot of experience now, solving a lot of issues which within L&T and outside L&T. So typically, where we started was, we started from our domain areas, and because L&T has a huge experience working in the industrial sector, including energy, transportation, manufacturing in particular, process and discrete, and construction. So we kind of developed these solutions internally, and in the process, we developed capabilities in the area of industrial IoT, AI, ML, smart manufacturing. And we did a lot of work on worker safety and availability, and that has really helped us, scale our operations and improve productivity. Track and trace logistics has been one of our core area in which we have been operating. Geospatial technologies, again, some of the members talked about how it can be used in the steel arena. So we have a lot of capabilities in this area. And of course, augmented reality and virtual reality. And based upon these capabilities, now we have a full-fledged offerings, which are, in the area of, so we have about almost 50 odd offerings, which are applications which can help optimize operations and do some of the automation works. Specifically in the area of the digitalization, you can see we have implemented these solutions at scale within L&T, and now we are doing it outside. So I mean, in our experience, we have got almost 11,000 odd plant and machinery instrumented. And that has helped us to oversee the performance on a real-time basis, monitor their productivity, help capacity utilization, and make sense of the data which is coming out. And we have our own AI platform, and we have developed our own gateways, which is basically an edge computing device which sits near the field and do the calculations and optimization. So we have a worker solution which is has been used extensively. Almost 3 lakh workers are now onboarded on that, and it is a full-fledged solution which will include worker safety aspects, onboarding the people, skilling, profiling them, and also monitoring the health performance and making sure that whatever work they are doing is as per the policies, and they follow all the safety measures. Coming to the steel industry in particular, the solutions which we have, they take care of the complete life cycle of a steel plant manufacturing process, which will start from, say, a mining, from where we can extract. When we are extracting the iron ore from there, our solutions start, and they go on from the time when when material reaches the plant and the whole process of steel manufacturing to the time when it comes out from the factory. So typically the solutions which we have starting from mine all include things like synchronization of operations in a mine, which will help optimize the kind of productivity is realized in a mine area. We can also have we have also solutions which are for condition and monitoring and predictive maintenance of the mining equipment, which helps maintenance of those equipments. And some of the people in the panel spoke about using drones for geofencing and stockpile estimation. So we have done that on scale, at scale in our operations. And so these are the solutions which are before the material enters the mine, the plant. And then in the plant we have optimizations on the whole process, which include condition monitoring and predictive maintenance of the key components, whether they are rotating equipments or the other equipments where we have capability to put sensors. One big area within the manufacturing plant is energy management, and it is important because almost 20 to 40% of the cost of steel making, is energy, which is kind of a forgotten field. But if we can optimize the energy consumption in each process, that can actually result in a lot of savings. So we have done that in a lot of our plants where we have captured the energy consumption in each process, making sure that there is no loss in a process. And overall, if we see, we have got tremendous achievements in terms of energy management. In a couple of plants, we have achieved more than 6% efficiency in savings. And because of the synchronization and line balancing of the whole process in a plant, we have achieved almost 7% OE increase overall. So that gives a kind of a impetus in implementing these digital solutions. And now these solutions can be implemented in any process industry. Moving forward, we have solutions which are for tracking material from the mine to the plant, and within the plant having visibility of the materials. We have solutions on fleet management or the movement of the vehicles within the plant, which is the cause of a lot of accidents. We have solutions for the complete automation of the entry and exit of the materials within the plant and outside the gate. Then fourth solution, which is of a lot of importance, is the worker availability and safety, where we manage the complete life cycle of the people, including the onboarding of the people, availability of the people, and then the safety aspects. So we have solutions where we can, through visual analytics, see whether they are wearing all those safety harnesses or the safety boots or any other PPE which are supposed to be worn during the process. And we have solutions which will help geofencing and enabling not making people go in areas where not supposed to go. Then another aspect is training of workmen through AR VR based safety training modules, which we have a lot of these ready-made for industrial usage. So these are typical solutions which we have. And if you'll see, we have achieved a lot of benefits out of implementing these solutions. Almost 15 to 20% reduction in equipment idle time. Then energy consumption, 20 to 25% in fuel consumption in the logistics area. We talked about improvement in OE in the plant, reduction in scrap and wastage, 6% improvement in energy consumption, and of course the other areas of worker safety and availability. So these are the solutions, and with this I will take a pause and invite any questions if you will have.
Thank you, Rohit. Thank you so much for your excellent presentation. But I must thank the person due to which you are here. That's Rachna Singh, your colleague who acts. So that's Ravi's daughter. And I must thank Ravi as well for taking the initiative to get me speak to Rachna. And that's how Rachna, in fact, told me that Rohit will be the one speaking today. So it was really, L&D Next was something which was unknown to me, though I have been in this field for the last 25 years. And if I may ask you, when was L&D Next launched? I mean, formally?
So formally, it was launched about 1.5 years back, but they're the same people who are working for the digitalization of our own internal thing, which was about 4 years back. So all those people would say, I would say this thing started about in 2016, beginning in L&T, where this group of people started working on industrial IoT solutions.
So Manish, let me tell you, you have good competition now from a major player who have been successful. L&T has been successful in various ventures in the steel and metals industry all through these years. And L&T has been a major player in the steel industry, at least whatever I know of. And with that, I would say you are in for competition now, because L&T will be able to, with this huge network within the country, and having worked with other divisions in almost every steel plant you can talk of. So I would say it is a run for your money. L&T Next is into it, and what we'll do is, Rohit will have more of interaction with you to see how best we can, at the same time, we have been promoting SMS Digital, Canelli, Trimetal. At the same time, how best we can promote L&T Next is what I'm going to look at. And when we get in touch offline, we're going to discuss various, maybe do an interview with you. Just like we did an interview with Mr. Bernhard Stinken, who's the CEO of SMS Digital in Germany. I think it was, Manish, it was last month or month before? I think last month we did.
I think it was, yeah, last month.
So in the same way, I want to give to be a platform where we give equal opportunities for everyone. So L&T Next should also be there with us in our journey ahead. And Manish has been always supportive of whatever. The moment he's in our WhatsApp group, the moment I posted my plan to do the Industry 4.0, he was the first one to catch up. And he said, I'll be there to give the presentation. And this I could do just as, Ravi's daughter recommended L&T Next. It was my son who recommended that I should go ahead with the Industry 4.0 series. So with that, I'll now move on to our next speaker, Mr. Kalyan Ram, Mr. Kalyan Ram is the MD and CEO of Electrono Solutions Private Limited. Mr. Ram, the floor is yours.
Thank you so much. Is my screen visible?
Yes, it is.
All right. So good evening, everybody, and it's a pleasure to be amongst such distinguished panelists. And thank you, Nirmala ji, for the initial introduction. So I would be trying to talk a little specific about some of the aspects of what we have been trying to look at on the machine side of the industrial IoT framework, specifically the downtime management and increasing productivity. So we've been working for a while on several aspects of Industry 4.0, with also from starting all the way from automotive OEMs and moving across several sectors. In terms of today's agenda of what we will be talking about, I would be touching upon, of course, Industry 4.0 introduction. A lot of introduction has happened, so I think I'll kind of skip that. There's been wonderful descriptions happening across. preventive, predictive, and prescriptive maintenance. On machines, I would be focusing a little more on the machine side, the TBMs, CBMs, DBMs, and so on, and some bit on the quality, of course, machine learning, artificial intelligence, sort of information on time series, cyclic and acyclic data specifically, and some examples. I will kind of skip this. I know that there's been a lot of discussion about all of these in terms of the technologies and frameworks of industrial IoT platforms. From this particular slide, I would have a focus on the industrial IoT platform, which has been in detail described as one of the fundamental components or the base of the pyramid. So as we all know, there are several challenges right from the base of this pyramid. It is not an easy game. There are several complexities at the implementation layers, which I would want to highlight and understand, and also connect with most of the participants here today to put up what we have noticed and observed through our implementations of several of such initiatives. I think to start with the challenges, one of the first challenges definitely, the legacy equipment. I have stopped here at 50 years. I'm pretty sure that you have a lot older infrastructure. I've just mentioned it as 50 years in terms of physical infrastructure, but what I meant was the kind of digital infrastructure as well. As we all know, in the steel manufacturing space, for ages, there has been a lot of evolution in technology as well, but at the same time, there is a lot of complex capital equipment, which is not easy to upgrade all the time, and it has its own complexities and reasons for why it cannot be upgraded. So I'm sure if you look at your own infrastructure that you have, that you're currently operating with, you might have sophisticated, fully computerized control systems in some of the infrastructure. Going a step backwards, you would have something like the PLC infrastructure, the PLC controllers, which are doing some bit of jobs, which I would call them as an intermediary technologies, which is almost anywhere between 20 to 50-year-old technology as a concept. You might as well have some technologies which are relay logic based, just push button electrical controls, basic control systems. At the same time, heavy electronic control systems as well, which is fully automated and also having high-end computation capability. So you have a wide range of controllers and computing platforms that are already there on your infrastructure. That itself is one challenge. Of course, because your production is a pretty complex infrastructure, the inability to shut it down to rebuild something is always a problem. Many a times, like what previous panelists have mentioned, it is not, cabling is just not a viable option in most part of the industry segment. So you need a lot of very, very precise and objective solution framework to meet these requirements. For all practical purposes, traceability, genealogy, and first in, first out would always be a matter of concern from the manufacturing process point of view. And the most challenging part at the lowest layer of this of the pyramid of getting digital framework done is predominantly having a consolidated data from different types of control systems. I'm pretty sure that you have so many makes and model numbers of the types of PLCs that you have. Some of them have Profibus, some of them has DeviceNet, some of them has Modbus, some of them are just RS-232, some of them don't even have communication. Some of them are already plugged into other devices. Some of them just don't have any mechanism to connect directly. So there is a whole lot of complexities that are present in the shop floor framework, in the manufacturing framework at your shop levels, to get several of these controllers connected to a digital infrastructure. On top of all this, as we have always seen, cost is always going to be a barrier for some of these implementations, because ultimately there should be a justifiable return on investment, which should translate effectively. So having said this, there are a lot of complex metrics that you would want to do, like the SPC charts that were mentioned. We can kind of categorize all these metrics into the categories of production, maintenance, quality, and safety metrics. And from those perspectives, having an overall equipment effectiveness at the individual machine level, into the total line level, your shop level, and so on and so forth, and being able to connect these dots, MTTRs, MTBFs, FMIs, and a lot of other maintenance metrics and quality metrics such as SPC charts talking about CPCPK and PPPK and so on and so forth. So these would typically be the challenges of primarily you're doing a lot of this already, but being able to connect the dots and create a central framework could be defined as some of the challenges. So getting down to the specific application, I just want to take a case in point and talk specifically about it, talking about a particular rolling mill case, having all its parts, as you are all very familiar with. The focus area, if you want to kind of focus on the transmission device infrastructure, we have the motor, the reducer gear, and the gearbase and connecting shaft. So basically, any measurement metrics that you want to do will start at the device level, which was very appropriately said by Mr. Manish earlier as well, that everything starts at the device level and then you kind of build upon all of that. So getting that from the device level, being able to actually integrate at the device level, and being able, and once you start getting the data, validating the data, I think that would be one of the toughest challenges that most of us are going to face when the data starts coming in. We have heard several times that tons and tons of data keeps coming, but how do you make sense of that data? So that becomes the first step. So in order to address that, one of the most important thing is to validate the data. There has been several discussions happening on the machine learning algorithms of several types, such as random forest and even including the statistical process metrics. So we need to we might want to kind of look at the source of these algorithms, how they were derived, what was the objective of these algorithms when they were actually being derived, and how that is going to get connected to the steel industry. As we all know, machines are generating the data which are real-time time series data. And these time series data, as many of them have mentioned earlier, are at the sampling rates of milliseconds sometimes. Of course, not always, but even if you look at specifically parameters such as vibration, definitely they are at least of the order of 1000 hertz. Otherwise, we wouldn't really make significant sense of data, because we have machines which are operating at around 20 to 50 hertz or up to 100 hertz. So it would be very important to pick the nature of sampling of data and being able to compute that complex information. So in that context, whether the statistical machine learning algorithms that are there currently, are they directly compatible, or before that, is there some sort of a data preparation algorithms that are required to be done, which are more engineering in nature, wherein we might want to first conduct certain level of data preparation methods, such as some sort of transformations, predominantly from time series to cycle series, time series to predominantly in terms of Fourier transforms. So these are all the transformation techniques that are required to be implemented before we actually get on to some sort of statistical functions, such as the typical machine learning algorithms. Even before applying the transformations, another fundamental step that is going to be a lot more difficult is to validate the data. You've got a lot of data from the machines. So this slide, we are trying to say that there is a shop floor data, which is going to translate into an information layer at the top floor. So right from the sensors, which is then connected to edge controllers or PLCs or CNCs, and then goes into a SCADA with some HMIs. From that layer of information, how that gets translated into a business information with certain level of analytics is a whole lot of transformation of data that happens. And I think in the journey, it is extremely important for all of us to understand what is anticipated out of this data, and whether the data is getting transformed appropriately at each of the levels, and whether the data validation has been appropriate at each of the levels. I'm sure a lot of people who have already started digitizing would have experienced that there is a lot of data out there. They are able to visualize the data. The data is supposed to show some information that is being anticipated, but it shows something totally different, or it is not able to be a perceivable data. So the main reason for that is it requires a whole lot of engineering preparation, engineering mathematical functions, which needs to prepare the low-level data, because they're all engineering metrics having a certain units and dimensions. And that preparation becomes extremely important before doing a statistical function. Some of that is exactly what we are trying to define as an architecture, whatever types of machines you have, including energy and all the sectors. The first step from data coming from all the machines with different controllers, different PLCs, and different OPC infrastructure, different SCADA infrastructure, would then come onto a digital platform where you have interfaces for data validation. So data validation is an extremely important process. I'm stressing it multiple times, primarily because this is most often missed and most often taken for granted. Unlike the financial, see, most of these machine learning algorithms have been kind of designed for financial sectors and some sort of mostly some sort of image processing technologies. That were the preliminary drivers of machine learning algorithms. So they have all have one fundamental assumption that the data that is incoming data is a valid data. Whereas for all engineering applications, and predominantly in industries such as the steel industry, engineering applications, the data is actually not valid. Most of the data that you are receiving is not necessarily a valid data. There's a whole lot of noise, whole lot of variances, and a whole lot of processing, cleaning up of data that is required extensively. So it is more complex than the regular voice signal processing, to be very precise, like what the Alexa and others does. So a whole lot of the data processing has to happen at the lower layers, which leads to a huge level of validation. So post-validation, everything else would become easier. If you're facing challenges with the data, the main root cause of the problem would be in the validation. All these layers are going to be more or less consistent. Some of the screens, what we have been working on, this is one of the specific case in point where we have noticed how the spindle, which is rolling the whole system, is having a certain sampling rate of data. And then if the sampling rate is not proper, we are not capturing the right information, and predominantly it will lead into wrong directions. So it's very, very important to identify the nature of sampling of data to be able to prove the appropriate point technically. So some such dashboards could help us. One of the case in point in this context is about the predictive analysis, which is predominantly a very interesting word for most of them, because we want to know what is going to happen in the future. That's always a human quest. So just to kind of define this at different stages, what happened, why did it happen, what will happen? Now that's the interesting part, right? What will happen and how can we make it happen? So what we mean by how can we make it happen is actually how can we avoid making something that would otherwise happen. So I think this is a journey that we are in this context. And a typical reliability engineering bathtub curve. So one thing that we should all understand from the Industry 4.0 perspective, as the whole concept per se is an early infant at this point of time. So this entire system of an evolution is more to be perceived as an infrastructure. It is not a solution like what was very nicely said by the earlier, that it is not a solution, it is not a product, it is not a technology, it's fundamentally an infrastructure. We are trying to prepare an infrastructure on top of which a lot of technology, products and solutions are going to come up. So the first step would be to focus on the infrastructure, keep the infrastructure ready, and then a lot of buildings, a lot of technologies can build on top of that. So this particular reliability engineering curve is as applicable to the Industry 4.0 infrastructure as to any other product development framework. So a lot of CPM, TPM discussions have actually happened. So I would kind of move a little fast on this because of the limitation of time. But any questions, we could always come and discuss more on that. We also have diagnostic-based maintenance and risk-based maintenance, in addition to the regular time-based and CPM. So we have a lot of algorithms running around that. So any discussions around that, we are most welcome. So two things before I close on, this is almost the last slide in my discussion per se. Fundamentally, we've got two types of parameters that we are dealing with in the entire world of industrial IoT. One is called the measured parameters and the other is called the derived parameters. Many a times, there is a huge difference between the measured parameters and the way we derive the derived parameters. And that is where the data validation becomes extremely important, because the measured parameters do not necessarily translate into the metrics that we want to define quality or production or maintainability or any of the parameters that you really want to see as an output. So these so-called measured parameters are going to translate into derived parameters from which a lot of insights are going to come. In the measured parameters, again, we have two types of parameters. One is the scalar parameters and the other are vectorial parameters. So it becomes a little important and interesting to understand these, to be able to perceive what we can actually expect as an output from this data. this is predominantly useful for any data scientist to understand the engineering elements of the data, to be able to perceive the data better and to derive at appropriate results. That is exactly what we are trying to define here: measured parameters, scalar and vectors, and derived parameters. And then a case in point is vibration. In that context, if you look at vibration, fundamental measured parameter is acceleration. You might have seen several sensors which are going to show velocity as a component, but the root component that is going to be measured in a vibration sensor is actually acceleration. The integral of acceleration is going to come up as velocity, and the double integral of that is going to come up as displacement. So it would be very interesting for all of us to understand what is the parameter that we really want to derive, or what is the parameter that we really want to notice in this whole context, and how a Fourier transformed output is going to actually show the necessary insights into a vibration infrastructure. So just to make one point here, if you take a rolling mill infrastructure, you've got a prime mover, which is an induction motor, which has a bandwidth of operation of around 60 to 130 hertz. Whereas if you take the bearings might have a bandwidth of almost like anywhere between 2000 to 3000 hertz. So having a vibration sensor on a bearing which is having a sampling rates of less than 500 or 1000 hertz is absolutely useless, because it cannot capture the frequency components of what you are originally intending to capture. And above all, if you're having a velocity type of a vibration sensor, I think we are missing the whole point here, because it is an integral output and does not have the necessary information for you to determine the frequency components. So having said that, and these are all just some of the information points that I want to put up, just to ensure that if you are choosing certain elements, we must be very concerned about what are the measured parameters, what are the derived parameters, what are the components of those measured parameters, and what is the sampling frequency, if you really want to get the right information out of it, and if you want to derive the right information from the measured parameters. With this, I come to the end of my talk. Anybody has any specific questions, I'm more than willing to answer. Thank you so much, Mr. Nirmalji, for this opportunity. Thank you all. I would like to thank Shrikar for also introducing me to this wonderful community and the group. Thank you all for this.
Thank you, Mr. Ram. Thank you, Kalyan. Thank you for an excellent presentation. And I think the first person who will be happy with your presentation is my son, Ankit, because you laid so much of stress on data analytics. That is what he is working on. He is working on the analysis of the data. This is of Ankit. Would you like to comment?
My area of research is not exactly data analysis. It's more like implementing machine learning to generate basically from knowledge to information, from information to knowledge, as they call it. But yeah, of course, I totally relate with this presentation. It was a very well elaborated presentation.
Thank you so much. And once again, I would like to thank my good friend Shikhar Shenoy for introducing me to you, and we will keep in touch.
Thank you.
I believe in building relationships. So once I build a relationship with you, it stays forever. So you are going to be in my circuit from today. That's for sure.
Thank you so much for giving this opportunity. Thank you.
Thank you. You're most welcome. Now with that, Debojyoti Roy, PEO of Tata Steel BSL, is having a problem connecting. He sent a WhatsApp message to me. So just see if he has joined in the participants part. If he is not there, we'll move on. Because I just sent him the attendees link.
Yes, I think he's joining in the panel.
Okay, that's good. So we'll move to Mr. Debojyoti Roy. Dada, can you hear me? Can you just, okay. Can you unmute yourself, Dada? Debojyoti Dada. Can you unmute yourself? He's already on the panel, right?
Yes.
Yeah. Dada, can you just unmute yourself and put switch on your camera? Debojyoti Dada, can you hear me? Okay, let him connect. In the meantime, we'll move to Mr. Praveen Casey, who's the digital solutions architect of ABV Metals. So, warm welcome to you, Praveenji. And just as I was mentioning, once we get connected, we can stay connected forever. And Industry 4.0 is all about connectivity. It is about connecting everyone together, connecting devices together. So with Industry 4.0, it's a good opportunity to get connected with you and the entire ABB team. So we will keep connected, but before that, I would like to request you to take the floor, and we'll wait for Devajyoti Roy to get connected so that we can pull him in after you. The floor is yours, Praveenji.
Yeah, first of all, thank you very well. Thank you and thank you for giving the opportunity. So good morning, good afternoon, and good evening. So are you able to see my screen?
No, we are not able to see the screen.
Share. I'm sharing the screen.
Ankit, this is not the Devajyoti Roy. This is Devajyoti Roy Chaudhary. You can just disconnect him.
I believe now you are able to see my screen.
Yes, we can see your screen, yes.
Yeah. So once again, good evening all. So probably I won't go much deeper because already we have discussed, maybe last 4 hours, we discussed about what is Industry 4.0, what are the things and what are the different technologies and everything, right? So probably I'll see some approach and where we are standing right now, right? I mean, our industry, where it stands. So ultimately, everybody want to move to a intelligent plant. So what is an intelligent plant? We need to get the information in our fingertip. So whatever, most of the plants still, if we go and get a morning stand-up meeting, there will be a lot of Excel sheets, papers, and mails. It is not like all these informations are collated. Another thing is, what about the predictability in terms of quality, productivity, and the reliability? Still, that prediction part is not up to the mark because we are relying a lot of things and a lot of what I'll say. Most of the time, our maintenance is still ongoing on the like a planned maintenance and the production plans and everything. It is just going on. Like, okay, we have a planning system most of the places or in an Excel sheet and going on. And what can be the quality or what can be the unscheduled thing and how we'll predict? No, that is not in place. Then how we are performing. So even though we say that our production is okay, we have a monthly target and we are achieving the target. But what about the productivity and how effectively we are performing? All these things need to be addressed. Even few of the places, even we say that this is an excellent plan, but still there are a lot of opportunity to improve. So those are the areas we need to work on. So when we talk about intelligent plan, the ABB, we work from the sensor level and different, I mean, you know that as ABB, you know that we have our own electrical equipment, we have our own sensors. Then we have our DCS and PLC and DCS systems and level 2 systems. We have our MEA systems. Then now we have a lot of solutions which is under qualified for Industry 4.0. Like it is having a connectivity, it is having a cloud of information processing, all this capability. So we call all these things like an ABB ability. It is an umbrella, ABB ability. So under ABB ability, we have a platform as well as different solutions for different industries or common things. And if we come into the particularly for the metals from planning, we have solutions in the stockyard management. But if you come to the raw material handling, we have a stockyard management solution we have, and we have some solutions for the conveyor monitoring, and conveyor prediction, and conveyor roller prediction. When it comes to the primary metals area, we have solutions on APC, and we have solutions on what I was optimizing the gas consumption and the energy when it comes to the hot rolling. In the SMS area, little tracking solution, and for the caster, we have solutions and expert operator assistant solutions are there. Cold rolling and the processing like profile mill. For example, if you want to detect the cobalt, we are working on one of the projects for the cobalt detection. Then we have a machine vision. Similarly, for the cold rolling, whenever from the pickling to from handling and pickling to if it comes to the CRM, whether we will be able to detect the defect of the coil. So those solutions and the shipping, the logistics part, when it comes to the rail, whether we will be able to reduce the demurrage of that, even if it is on the shipping, like even in the logistics shipping, whether we will be able to reduce the demurrage. So we have the solutions, right? We have multiple solutions in each of these areas. I don't want to go to pinpoint each of this area. Importantly, what I want to stress here is we have a solutions which works on the data as well as closing the loop. That is very important, right? Once we are getting the insights, how we'll close the loop. So if you want to make an action, so our solutions mainly we will concentrate getting the data cleansing, then making the insights and putting our domain knowledge as well as the customer domain knowledge. Because you people are the masters of your plant, and all plants are different. There will be commonality and there will be different, uniqueness, right? So those things we will work with the customer or with the end user, then we will put it, then we will close. Okay, we need to have an actionable insights. Yeah, what action we need to do? Whether we need that in terms of a set point or we need to do some other action. So whether we need to go for like an advanced process control, where we need to go. So those actions or close the loop so that we will take care. So we have a solution suite. I'm not saying like I have all the solutions, but in each of this area, we have a lot of solutions which we develop from our experience along with the customer. So it is like a collaborative approach. We have developed a lot of solutions. And importantly, what is the value chain what we speaks about, right? So in Industry 4.0, most of the guys, most of the time, everybody thinks about like, okay, I need an AI-based solution. Whether do you have an artificial intelligence in your solution? Answer is yes. But to reach over there are different steps, right? We'll see that how that is. First of all, majority of the plants, they are not even connected and fully connected. Their operations are in silos. A lot of isolated operation is happening. So as Ram told, getting data, okay, everybody say that like data is the, I think another fellow speaker also speaks about data everywhere, but what is the quality of data we have? How we will get it? So getting the information, contextualizing, connecting between the systems, that is the first task we need to do. Whether we have that infrastructure, yes, we need to invest. When we need to get those benefits, definitely we need this data. We need to invest in that approach we need to make it. Once we have all this information, then we need to go into a operation optimization or a collaborative operation. How we will do on that? So that we need to work. Then we'll see on the business optimization. Okay, now I have my operation information with me. So this information with me. This is the business need. How I'll be able to correlate. How I can reap benefit out of that. Right? Then we'll go to the autonomous. So this is a different step-by-step approach. So we need to see about the infrastructure. Then we need to see where we are standing right now. Then we need to move. I'm just skipping this. Okay, this is a study. And when we speak about Industry 4.0, everybody have a role in that. It is not only for the CEO. Most of the time, or right now from 2016 or 2017 to here, there are a lot of changes. Now, most of the organization is having a digital organization and they have a digital team where they are defining, okay, how I need to go. They are preparing a digital roadmap. So it is not an initiative from the top management. Each of the plant people, each of the role have a vital role to play to have a success, and they have their own benefit out of that. Even from an operator point of view or a supervisor point of view or a functional or a mill manager point of view or a plant manager point of view or in a C-level. So everybody is getting a benefit out of this. That is in terms of either they are going to get much more benefits in terms of decision making. They are getting a lot of information and they will be able to improve their productivity. In terms of plant manager, he is getting an overall 360-degree view. In terms of C-level organization, so they have a multiple plans, how each plant is performing, where they are losing the money to the dollar value. So in each of those levels, we are getting information. So as I told you, the important thing is where we are standing right now. So what is the digital roadmap and where you are standing? The benchmarking is important. Where is your plant right now? Whether it is in a partially automated or a locally automated or a connected or in a collaborative, then only we will be able to move to an autonomous or in a full-blown Industry 4.0. I'll say that like a intelligent plant. Everybody's aim is to go to an intelligent plant, but there is a different steps based on our current where we are standing right now. Accordingly, we need to make a roadmap and we need to choose a solution. Ultimately, each of the phase, I say ROI is important, right? Whenever a single penny we are spending, we need to get the returns. And specifically in the digital, it is like less than 6 months time or a 1 year time. Again, based on the initiative, people are thinking of the CDOs or CFO is thinking about it. It is important to see where we are and what is the benchmark and where we need to move and how is that approach and what are the phases. So ABP can help you over there. And mainly we are concentrating in 3 areas. One is on the platform and analytical application. Basically, you need to integrate your different systems. As previous speaker mentioned about, we have a legacy systems, new system, different vendors. So horizontally, we need to integrate, right? You have a different kind of solutions, different vendors, different automation vendors, different sensors. All these things needs to integrate it. You have a quality systems. So horizontal integration, then that needs to be integrated vertically to the MES and the ERP of the next level. So integration is one part. So that is one suite. Then after integrating, after getting all this information, we need to have a contextual dashboards, data-driven decision making. So you can browse and you can get the data, you can slice and dice the data and you can get it, and root cause analysis, then put on the ML algorithm, AI or ML, whatever. Then on the optimization application. So now I understood, okay, these are the places where I need to go and optimize few things. Yes, we have an optimization applications. We have a mainly on this MPC, modified predictive control, or APC, which is based on the neural network and machine learning. We have a application. Then tracking and scheduling. This is one of the important things, right? Okay, how is the ladle an SMS? How will track, or the torpedo ladle? How we are doing? How your crane is performing? What is the optimization in your yard, slab or coil? So this tracking and scheduling optimization. Then the next one is on the asset part. So how condition monitoring and the prediction, and then overall anomaly detections and everything. So these are the three main brackets or main, I'll say, pillars we are working on. We have solutions for all those areas. And what is our approach? It is like, we would like to have, I mean, definitely, whenever we say, okay, there is a requirement, we are willing to conduct a workshop with end users and the stakeholders, and then define the scope and solution roadmap. One of the challenge, what I face, even all the organizations, most of the digital initiatives, up to certain extent, we have clarity, and rest of the things are like a new technology, right? There is a challenge when we speak, okay, what is the benefit, how we need to take it? So that we need to work on together. What exactly the scope and how is the roadmap, how we need to take it up, how is the ROI, and how help. Whether you need to have a POC or a pilot program, definitely, yeah, that is the way we need to work on, then go for the implementation. So this is the approach ABB used to take it up. So that's it from my side. Yeah, I think I'm on time, I believe. Maybe 1 minute.
Thank you so much. Thank you, Praveen. Offline, I'll get connected with you because your presentation was again of a lot of interest to me, because you went into the details so very well in every aspect of plant management. And as you said, at every level there is a role to play in Industry 4.0. So that is a very point very well taken. And with that, I think Devajyoti Roy was not able to join. So we will have to start summing up. And Subrata, now it's over to you to sum up what we discussed during the last 4 hours. Yeah, exactly 4 hours. So
thank you.
Yeah, so it is over to you, Subrata. Mr. Subrata Mitra, our Chief Editorial Advisor of the Editorial Board, and then he's ex-Joint Managing Director of Evan Dastur. So, a person with a huge amount of knowledge. Every morning, every single question which comes to my mind, I ask this gentleman because of his knowledge base. It extends from, you start from cinder plant right up to, let's say, the town coiler. Everything is his domain. With that, I'll hand you over to Mr.
Thank you, Nirmalo, once again for your good words. Anyway, so after the welcome address by Ankit and introduction by Nirmalo, the first speaker was Subhashaji Bandyopadhyay from US. So he was right in his deliberation. When we started, and he started a little later than me from the same plant. When he started, he said 90% of the work was brownfield, means manual, getting dirty in the plant, manual work, not much of brain work, and little, about 10% only was brain work. Now the younger generation do not like such things nowadays. So unless the industry is tech savvy, people will lose interest in the steel industry and it will go haywire. So this
awareness of Industry 4.0 or digitization, whatever you call, is not only helping the business of the industry, but it is bringing the younger fold into the industry back. So a simple example, huge amount of yield loss happens in the industry for not adhering to modern automation or these techniques of may not be directly industry 4.0 to the fuller extent automation. So another example he gave, wastage of steel due to this yield and non-conformance to the product quality is losing 9 to 10 billion US dollars. So that was a very good thing, and he insisted on training, which is very much required. The next speaker was the keynote speaker, Mr. M.P. Dubey, Joint Director, Andhra Pradesh Software Development, STPI, which has opened up in Vizag, which of course many of the panelists or us did not know because of the pandemic. We can't help. That was setting up India's first Center of Excellence. So he gave a presentation, detailed presentation on and talked about emerging technologies, 3D printing, nanotechnology, and whatnot. AI related, huge amount of work is being carried out there, and attempt is made. 30 odd engineers have joined there, and slowly it will expand. With this AI market growing, it is predicted the CAGR growth rate will be 17%. They are taking up machine learning, artificial intelligence, AI, bioinformatics, and or cloud computing and whatnot. SMS, CIMAC, and Danieli are right now the partners, including robotics. So use of drones are also being studied. The good thing and another good thing Mr. Dubey has pointed out that active participation from domain knowledge experts as mentors are requested. That's a very good proposal he has given, so that industry experienced people can act as mentors and grow this center of excellence and adequately, so that it ultimately helps the country. CMD RINL is the chief mentor of this center of excellence. Then came Mr. Ravi Singh, CEO of Full RIN. He shared the importance and the things what can be done. He stressed on economics that AI will provide after implementation, and gave certain examples. Spoke about different levels of automation that needs to be carried out. E-commerce, stressed upon, which was there earlier, is coming back in full swing with this endeavor. Shared certain flow patterns of what is being done in his industry, and we also suggested Google-based maintenance and including SAP interference in all these endeavors. Then Mr. Alessandro Ardesi is from Danieli Automation Director. He spoke about the actual operational practices that Danieli is pursuing. It's called Danieli Intelligent Plant. He gave an idea of the pulpit, 3 pulpits, number of pulpits, or operating from only one pulpit, which will show all the activities. The next generation pulpit is being worked on by Danieli, which will club number of pulpits into one for the ease of operation and utilizing lesser number of people and crowding in one place. Connectivity and remote support is also being offered by Danieli, that is operating from the different country plants and suggesting operation and maintenance, and actually operating from a remote location. Then the fifth speaker was Mr. Saurabh Ganeriwala of GSPL. He is a chief digital officer, presented the digital framework for the steel industry, which GSPL is thinking now. Talked on relevant points of the steel industry that is important to be taken up. Real-time operation data's importance was highlighted by him. he spoke on digital journey and the value of human expertise, retaining value of human expertise was also stressed upon him, without which no system can operate. This is a good point he said. And the sixth speaker was presentation given by Mr. Manish Bhatt of SMS. He talked about the asset health evaluation which they do. Customer gets 6 to 8% of profit through the product quality different initiatives. They had asset health evaluation, product quality, production planning, predictive energy management, predictive product quality. Through all these, the customer can easily get 6 to 8% benefit profit after implementing all this. Reduce downgrading. This initiative will reduce downgrading and quality incorporation of the quality systems which SMEC can offer services. In MES 4.0, it was also talked about. What he said, cost, efficiency, and emissions together can save on emissions, increase efficiency, and reduce cost. Certain two examples he gave: LD converter slopping prediction control, slopping control. They have worked on that, and caster slab longitudinal crack elimination. Then certain, it's not exactly 5G or whatever, but control based on pilot projects in building means connectionless torque amplification project is taken up through remote control without cables, without wires. Mr. Ashok Biswal, PGMRI, cited some actual practical problems at site. He wanted help on 10 problems for discussions in the next webinar, which we are planning for the SMS area only, alone. Because the SMS steel making area is a vast area, and he has cited 10 pertinent site-based problems which he wants to discuss. Mr. Ram, Mr. Ravichandra, JSW Bonnet Director, and Salem and JSW Bonnet, he talked about 20 initiatives that Salem Plus Bonnet is carrying out. Ferroalloys for the one very important thing what we cited was ferroalloys cost reduction, which contributes to a large extent. 2 to 3% reduction in ferroalloy consumption saves about 4 to 5 crores. BF gas flaring saving is also very important. Unusually, last minute gas is being flared, controlling that. Then also some social distancing and vehicle movement problems are being handled to their initiatives. Sinter return fines reduction has been achieved. Hot metals variability reduction analysis is being carried out, and looking for optimized production from Salem steel and pellet size optimization, because variation on pellet size is not operationally favorable. And the ninth speaker was Mr. Mohile of JSW. He once again elaborated JSW's culture of innovation and implementing good ideas, which is beneficial for the plant in different aspects. Phosphorus control prediction is being worked on. Quality prediction is being worked on. Maintenance prediction is being tried now. And drones, utilization of drones for logistics control and profitability for logistics control is being carried out. In each area of the steel plant, 25 to 30 projects are under implementation by JSW. Mr. Ramchandra Chakraborty of ESI, he related with reasons why to change to Industry 4.0. What is why it is required? So we nicely elaborated the reasons required for rapid market change. Unless these are taken care of, companies cannot survive and be competitive, and quality assurance cannot be achieved. Real-time data use for digitalization was highlighted by him. 11 speakers were Mr. Rohit Gupta of L&T. L&T started this initiative 4 to 5 years back So the new company has been quoted L&T Next NXT. We started with the domain area, expertise area which L&T has. Say developing processes internally, worker safety, which is very, very important for a company like L&T. Logistics control. L&T can offer has 50 offerings to make. Optimization of operations, servicing start from mining to condition monitoring and maintenance, drones for stockpiling, fencing, tracking materials. These are certain initiatives, to name a few, which L&T is working on. So, and that is also helping in reduction of 15 to 20% in the idle time. And the third speaker was Mr. Kalyan Ram, CEO, Electro Solutions. Preventing their initiatives are rolling mill downtime reduction, preventive maintenance planning, predictive maintenance also. Predictive means you can predict at what time the maintenance shutdown needs to be taken. 110 initiatives are in their planning. Current challenges is implementing industries. Various implementing challenges is shared. Manufacturing phase architecture was shown. Reliability engineering topic, which is very important, was highlighted by you. TBM is time-based management, and condition-based monitoring was also talked about. Time-based monitoring and condition-based monitoring. So the 13th speaker was Mr. Praveen PC of ABB. He talked about the intelligent plant model which they are working on, solutions for planning, stockyard management, primary steel area, rolling mills, various hot and cold rolling mill area. One good thing, what they are working on, demurrage reduction for shipping, which is very, very important. Means whenever material comes, it's stopped, and a lot of demurrage has to be paid. So demurrage control in shipping, solutions which work on data, and the whole purpose of their work is solution which work utilizing the data and closing the loops. I mean, just getting the data is not enough. Closing the circuit, utilizing the data. It's called digital value chain is being utilized to the full extent. Digital roadmap for metals industry was shown by him. 3 areas specifically highlighted: data platform, process optimization, and asset management. Mr. Debojyoti Roy, Pakistan BSL, unfortunately could not join. So this is, according to me, whatever was discussed, and were very value-added and knowledgeable and experienced panelists spoke on these subjects. Thank you, all the panelists.
Thank you so much, Subrotada, again elaborately summing up the entire session. Now, what we'll do is, as the next action, as we always do, we will send the entire summary of today's event to Mr. MP Dubey, who is with the Ministry of Electronics and IT, Government of India, so that Ministry of IT takes up Industry 4.0 for the Indian steel industry as a hot topic within the government, and also we'll send it to Ministry of Steel, to our Additional Secretary Ratika Chaube, Madam, so that Ministry of Steel also gives a thrust to Industry 4.0,
Okay.
which is actually a roadmap to reduce the cost in the long term, as well look at profitability on a quality aspect. Yes, very much. Look at the quality aspect as well. So with that, thank you, Subrotada. We are almost at the end of it. I would request my son Ankit to propose a vote of thanks and finish off today's session. And very soon we'll have the second session on Industry 4.0. I'm sure Manish, Ramda, Praveen, Mr. Ardesi will also join in the input to look at various issues which we need to address in Industry 4.0 for various, right from steel making down to, let's say, logistics, wherever we can use the Industry 4.0 base for artificial intelligence, for machine learning, everything together. So with that, may I request Ankit to propose a vote of thanks. And I thank everyone once again for joining these last 4 hours. Ankit, over to you.
Yeah. So thank you all. Thanks to all the panelists and the attendees who have joined us today. We managed to discuss a lot of important topics about the future of the steel industry and the direction the industry will be taking in coming years with Industry 4.0. To make this event possible, I would like to thank SMS Group uh, for being our co-sponsors, without whom we wouldn't be able to make this event. Special thanks to everyone in the organizing committee, led by Mr. Shubroto Mitra and Mr. Shobhujachi Bandyopadhyay. And of course, a big thanks to our technical partners, Amitech India, and everyone from the Steel and Metallurgy team who helped make this event a successful one. So thank you all for joining us, and we will see you again in our next webinar.
Thank you. Bye-bye. Bye.
Bye-bye.
Good evening. Bye.
Thank you.
Ciao.
Bye-bye.
Ciao. 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 Ciao.